Hi everyone. So we have 10 more minutes left until the start of the session. So in case there are any questions, feel free to put them in Discord and then we can handle them. Right. I see that some additional people have joined, so if in case there are any questions, feel free to ask them in Discord, right? Otherwise, we start in about 8 minutes. Maybe while we're waiting, since I don't really see any questions. One thing that was mentioned in, I think it was the first session, and I think it was John that posted this, saying that the password resets do not revoke refresh tokens anymore. So I said I would look into that, and yeah, well, it depends, right? Normal access tokens or normal refresh tokens obtained using normal password credentials, normal password authentication, and multi-factor authentication will still be revoked if the password is reset, right? However, if you use a non-password based, or if the refresh token was obtained from a non-password based authentication, then it will not reset that because it would not really have any effect, right? Because the user or the attacker in that case would not have access to the password either way. So no need to reset these refresh tokens, right? So the reasoning behind this is if the user's password is compromised, then an attacker might have gotten access to some refresh tokens using that compromised password, right? So if we reset that, the password, then all refresh tokens will be revoked that were obtained while the attacker had access to that password, right? But it would not make any sense to revoke all other refresh tokens, right? So thanks for sharing that. We have a question from Andrew. Can you show us how to disable the device code authentication? Sure. Let's actually go to the student VM. So you can't really disable device code authentication itself. However, you can, since earlier this year, create a conditional access policy. So if you go into conditional access policies, let me zoom in a little bit. And if you create a new policy, for instance, let me move that out of the way. What you can do is create a block rule. So if you go to grant and select block access, to block any type of access over there, and in the conditions, in the conditions, you would go to authentication flow. So this is the new setting that Microsoft introduced. What you can basically configure here is to block all authentication attempts from a device code, after device code authentication. So what this will basically do is the device code authentication will still go through, but after that, conditional access will block the user. So the user will still be able to enter the code, sign in, and then they will get a conditional access block, and the attacker will not get a refresh token and access token. They will not even know that the user attempted to sign in over there. And the legitimate user that is being phished will see a conditional access block page. Right? So this is how you would do that, right? With grant block, and then you can just say configure this for all users, or if there are a couple of users that do require device code authentication, maybe some of your IT people do need that, and you can exclude them from this policy, for instance, right? Awesome. But by default, it is enabled in all tenants, right? Device code authentication. So we still see device code phishing being quite a big issue for most organizations, right? Because they are not aware of the specific technique itself. Any other questions before we start? So a question is, what does phishing resistant authentication actually mean? Right. We will go over that in this session. Right. So we will show you what that specifically entails later on. I think in Kill Chain 3, we will go over that in detail. Right. So I'm gonna hold off on answering that question a little bit, but you should get your answer by the end of this session. Awesome. So a comment is that most organizations issue devices, but then they don't do authentication based on the device compliance. Yeah, indeed. Device compliance and conditional access policy is actually very strong because it is very hard to bypass a conditional access policy requiring a compliant device, right? Because as an attacker, you would first already need to be able to have compromised the compliance of a hybrid device. Or in some cases, you can create your own device, join your own device. But even that, you should also restrict that users can only enable their device using multi-factor authentication, and maybe even only allow it from your trusted company IP addresses, right? So the question is, why do they not use that more often? Well, in a lot of organizations, the better organizations, they will use that, but indeed the majority will not follow that so tightly, right? So they will also allow users to sign in from non-compliant devices, right? And the reason usually is because it's more convenient for the users, right? For instance, you have your CEO that needs to access his emails from his mobile phone, right? And maybe he has a couple mobile phones and he doesn't want to join them all to enter ID, right? Yeah, a lot of reasons, but mostly it is usability, right? Um, and the fact that you need to configure it, right? So default security will mostly be the security that you see in most organizations, and by default, there's nothing that will be enforcing that, right? You need to create the policies yourself and manage them and ensure that there are no issues in there. So the question is Burp Suite able to bypass the FIDO parameter and allow login without multi-factor authentication? Um, so if there is a conditional access policy that only allows you to authenticate to a specific resource using FIDO authentication, which is something that you can do, we will go over that later on, then you will not be able to bypass it like that, right? However, if a user has FIDO authentication set up, and you also allow that user to sign in without FIDO authentication, you also allow that user to just sign in with their username and password and some other type of multi-factor authentication. Then if you are a man in the middle, right, if you are able to change the request of the legitimate user, you could, for instance, return a web page and instantly let the user fill in their username and password and not prompt them to use video authentication, right? If that is what you are referring to. Yes, exactly. All right. Any questions, other questions before we start? Okay. So I don't see any other questions. So let's start this session officially then, right? So welcome everyone to the second session of the Attacking and Defending, or no, the third session by now, of the Attacking and Defending Azure Cloud Advanced Edition of the October 2024 batch. Right, so this is session number 3. After this, we have one more session. Last time, we completed Kill Chain 1 completely, right? And we actually started Kill Chain 2, right? So if you remember what we did last time, we got access to a drill planning application. The drill planning application, this was a web application that was vulnerable to the no-out vulnerability, right? So what we did was, with our student credentials, with our attacker credentials, we modified the email address property in our attacker tenant of this user to contain the admin keyword. And this specific application, the drill planning application, was only checking if the user had the admin keyword in their email address, which obviously is not very secure. So we were able to gain access to the drill planning application as with admin privileges, right? And there we saw that with the admin privileges, there was some functionality on the web application to create a new account, right? There was a button at user, which in the background, we didn't really see that, but in the background, it sent a trigger to a logic app, create credential object, which created a new user in the target tenant that we were targeting. So the Well Planner X user was created, and the credentials of that user were returned to the web application, right? So we got access to that Well Planner user. And this user is also a member of the drilling IT group, right? So what we will see later on is that this Well Planner user will have some access over a logic app, right? So for that, let's actually continue from where we left off and first discuss logic apps a little bit. Right, so what are logic apps? According to Microsoft, they are one of the currently four workflow creation services in Azure where you can create and run automated workflows with little to no code. Right, little to no code, meaning that it is a simple drag and drop functionality. You can use a little bit of code in there if you want, right? But for the most part, it will be a visual designer, as it's stated here, right? Where you can just automate some stuff. So one of the currently four workflow creation services. What are the other ones? So you have Azure Functions as well. So that is more useful for or more intended for service to provide serverless compute services, right? So mostly used by, for instance, web applications to create a simple API interface, right? There it is low code, so there will be various types of code available, and you can also have a little bit of drag and drop functionality there. Then you have Power Automate, right? So that is a little bit the logic apps, but not for the IT users, right? So logic apps is more focused on IT persons, while the Power Automate is more focused on business users, right? So there you can automate business flows, right? So even non-IT person should be able to work with that and, for instance, create a workflow where if they get an email, for instance, it will automatically maybe create some type of create some type of file in their OneDrive, for instance, or maybe automatically reply to that, or it will monitor their OneDrive, and if a file is put in there, it will automatically do something with that. So that is what Power Automate is used for. And then the last one, we have automation accounts, right? So there you can have runbooks to automatically do some stuff in Azure itself. So that is mainly used to automate the resource deployment in Azure, right? So you can create and manage all types of Azure resources with that. Yes, exactly. Like John puts it, the logic app is admin-based, so it requires an Azure subscription. Power Automate is indeed not really truly part of Azure itself, right? So for that, you would need a license in Microsoft 365, right? It's part of the Microsoft Power Platform, right? So what can the logic apps be used for? So we said it a little bit already, but these are some examples that Microsoft provides, right? So you can, for instance, create email notifications when a specific event happens. We'll look into later what these events can be. You can, for instance, upload files from an FTP server towards an Azure storage, right? So as I said, really, really IT-focused workflows, right? Monitor social media, for instance. All of the things you can do with that, yeah, basically whatever your imagination can think of, right? You can probably automate that with logic apps. So let's look into some terminology first. We will show you each component of a logic app in a little bit more detail later on in the portal, but let's first cover some of the terminology so that we're all working with these same words, right? So we have the definition. So this is a JSON document that contains the structure of the logic app, right? So the structure of the logic app. So this definition will contain, you will see later on that the complete workflow will be defined in that, right? So what is the workflow? This is actually the series of steps that the logic app wants to execute. So this is what you want the logic app to do, right? That will be defined in a workflow, right? And a workflow can have several actions. So actions are the operations and tasks that are actually being performed. So how do you actually initiate the logic app? So for that you would need a trigger. So there are several types of triggers. For instance, if a file is uploaded somewhere or if a new email is seen, that can all be triggers. However, a very common one and one that we will look into a little bit deeper is the HTTP request, right? So you can send an HTTP request to a specific endpoint, which will be called the callback URL or the workflow URL, right? Which is mentioned at the bottom over here, which is linked to a trigger of a logic app and is used to actually trigger that logic app using a simple HTTP request. Right. Think of it as it is just a webhook, right? It can be used for all kinds of use cases, right? So for the defenders over here, a lot of you will probably already have heard about canary tokens, for instance, right? So you can create a canary token and put a URL somewhere, and an attacker can see it. And if they interact with that, or if you can also make some functionality that if they open a specific document, for instance, it will automatically send a web request, right, to notify you that someone is snooping around at some places where normal users don't go, right? So for that, you can perfectly use logic apps, right? That's very easy to create. Just create an HTTP trigger with a callback URL and put that somewhere, and then if that logic or if that trigger gets initiated, right? If someone visits that, you just create an alert however you want, right? You can automatically send an email to yourself or create a ticket in your ticketing tool, for instance, right? Some other things that we haven't covered yet are the connectors. So this is basically used to allow your logic app to take some actions with some privileges, with some credentials, right? So in here you can, with connectors, you can actually give your logic app some rights. For instance, you can create a connector to allow it to send emails on behalf of a specific user, right? Without credentials to a mailbox, it will not be able to gain access to that, right? So that's where you can use connectors for example, or you provided some access to some resources, right? Parameters, so these are mostly used with HTTP triggers as well, right? So in your logic app, you can create parameters that will change the flow of your logic app, right? So you can, for instance, have a parameter, let's say, name it action, for instance, and based on the parameter, on the value of the parameter that is provided by the user when triggering it, your logic app can do some take some different branches in your logic, or it can be used to manipulate some data, for instance, right? We will see that all a little bit more in a more tangible manner a little bit later. So logic apps, yeah, is basically it contains most functionality that you would see in a basic programming language, right? So you will see that there will be conditional statements. So right, so if else statements, right? If a specific condition is true, then do this, otherwise do something else, right? Switch statements, probably know what that is. If it will look at the value of a variable and take a specific path based on that specific value, right? You can have branches to run actions in parallel. You can have loops to repeat actions. You can have scopes to run actions only after another group of actions succeeds or fails, right? So let it wait until something else has happened, right? So a lot of things that you will probably recognize from programming, right? There are two types of logic apps. You have the consumption workflows. So this is basically the pay-as-you-go model. So if your logic app doesn't run, you don't pay, but every time it is executed, it will cost you some money, right? Uh, so if you use consumption workflows in logic apps, then there are these kinds of roles that are linked to that, right? So you have the logic app contributor, you have the logic app operator, and you have obviously your classic contributor on the resource level as well, right? However, there's a second level or a second type of logic apps that you have these standard workflows, right? So this is or was in preview at least, and that works based on an app service plan, right? So that means that you will just basically pay a static amount of money, right? And even if your logic app doesn't run, you will pay that. But over the long run, if you execute it more, then it might be a little bit cheaper for you, right? So depends on how you want to use it, right? And for the logic app standards, you have different roles. So you have your reader, operator, developer, and your logic app standards contributor, right? So if we encounter logic apps, what are some things that we can abuse within logic apps, right? So obviously, everywhere that users can configure secrets, there might be secrets, right? So where would you find secrets, for instance, in a logic app? So there are a lot of places where you can find that. For instance, in the run history, if you have read access over a logic app and are able to read the run history, then you might find some secrets in there, right? But if you have read access to the workflow itself, there can also be secrets, clear text secrets configured in there. It's not best practice to do that. You're better to use connections where the secrets will not be directly visible to you. However, people will still put secrets in the workflow itself, right? But also the output, if you're able to trigger a logic app, in a lot of cases, if it is using an HTTP trigger and you know the callback URL, in all of cases, it will not be restricted from which location you can execute that, right? So it is possible to restrict from which IP address a logic app can be triggered. You can also add authentication on that. But in a lot of cases, you just see that they want to push something to production, they want to start using it, and they forget about putting security on that, right? So if as an attacker you find a callback URL, then you might be able to trigger that and you will see sometimes see some sensitive output being returned, right? And even if it doesn't return sensitive output, the logic app will still be doing some actions, right? So depending on what it is doing, you can maybe still influence that or take advantage of that, right? And with workflows reads, we can see some sensitive information, as I said previously, right? So where can you, for instance, find a callback URL? So in a lot of places, of course, if you it sometimes might be found in documentation that you find somewhere on SharePoint, for instance, or it is emailed somewhere, or you compromise an application that is calling the logic app itself. Browser history, if you compromise a device, you can maybe find it in the browser history, right? URL logging. So if you compromise, for instance, a firewall that logs all requests, if you get access to that, you will be able to find that maybe there, right? So a lot of places where you can find that, or if you just have the right permissions in Azure itself, you will also be able to just read the callback URL. We will show that later on, right? Which brings us to learning objective 8. But let's first, before we jump into that, show you some stuff on the Azure portal. So the question is, can the Azure reader role read the run history or input parameters? or is a specific logic app role required to read that? I think it will be somewhat limited. So I have encountered that on assessments. I don't know it 100% for sure, but I think there are some things that you will be able to read with that. So usually you should be able to read the workflow itself, I believe, and also the run history itself as well. But it will be limited. It will not be, you will not see everything, right? So something I would need to look up in the documentation. So let's go look at a logic app portal over here. The one we want to look at is the optimization logic app. Thanks. All right. So what do we have over here? So here you can obviously already see the run history. Obviously here we're logged in as an administrator, so you can see everything, right? If you want to see the actual flow, how it looks like, the visual designer, you can see that over here, right? So like I said, there's a trigger over here that you can configure. There's a switch statement and a specific case that gets executed, right? Based on that input, based on a parameter that's provided in the input, right? We will not go into too much detail because we will look at how we can enumerate it later on as well, right? But you will see that a different type of response will be returned based on what type of input you provide, right? You will also be able to see the code view. So remember where we talked about the definition. Here is the definition for you, right? So what will be in there? So all the actions that will be executed. So these are all the blocks of code that will be executed, right? And a little bit information about the trigger as well. So you see there is a trigger over here, and there is some type of parameter over there. So as you can see over here, the parameter is used in a switch statement later on, so an action parameter, right? We'll look at that a little bit later, right? Okay. Anything else I want to show you over here? Obviously, you have your run history over here, so there you will be able to see what flow got executed, right? So you can really see which path that it went through. You will be able to see the output of each specific action as well, right? So you can use that to debug your logic app. And even here, you can sometimes find secrets, right? For instance, if there is a specific type of action to perform an API call to a some third-party application that might contain some API keys, right? Or if it's doing authentication to obtain an access token, you will maybe see the access token in the output or in the HTTP response from the API call, right? Is the logic app designer going away? I don't think so. Did you see that somewhere? Logic app code view. The legacy designer. So might be that yeah, yeah, indeed. They changed it recently, but it's not going anywhere. Yeah, no, you will still need some way to actually design your logic app, right? So maybe they changed it. It will get a or get a different look here. You have to enable legacy designer, right? So we will not do that because it might delete some stuff, but it will just look differently. But the designer is not going away, right? So otherwise the logic apps would not have much use anymore. Yes. All right, so let's get to the learning objective, right? So using the privilege of the Bell Planner X user, treat the workflow of a logic app, right? So remember, as I said at the start, this is where we were, right? We previously got access to the Bell Planner X, its clear text credentials, right? So let's connect with these credentials towards Azure and see what we can find. Right. So these were my credentials. The event Bell Planner user that was created for me. So let's connect to Azure. And we already see that we have access to a subscription, so that's great. That means that we will have access to some Azure resource at least, right? Let's look what Azure resource that will be. We get easy resource, and it seems like we have access to a logic app, right? Which logic app? Well, planning logic app. So this was the one we were looking at over here. No, it was not. We were looking at optimization logic app. That's fine. This logic app will work a little bit the same. Right. So let's actually first check what permissions we have over the specific logic app. And obviously it will not work again. Right. So get easy rule assignment, not always the most consistent. So what we can do is, as we have done a couple of times already, we just request an access token for the ARM API, and then we will just send a manual API request. Right. So what API request? We will request the permissions of this logic app, right? So we only provide the ID after that of our resource. So as you can see, where can we get that? This is this, right? So we just copy that, put that in there, and then add that at the end to list permissions we have on this logic app, right? And it's a simple GET request. So let's send that and see what permissions we have. We have logic, the workflow is read, so we can read the workflow, and also some additional one where we can list the callback URLs, right? So remember the callback URLs, they are linked to a HTTP trigger, right? But with only read permissions, you will be able to see the workflow itself, but you will not be able to see the trigger URL, right? Which might be a little bit weird, but that's how it is. You need an additional permission for that. This is the permission that you need to list callback URL action to list the trigger. Let's start by enumerating the logic app itself, right? So get easy logic app, and let's format some of the information that you want to see. So we have the well planning logic app. It is enabled. We can see when it was created, when it was last changed, right? So some information that you might want to look at. What else do we want to see? If you want, you can also just request the complete definition, right? So we're listing the or retrieving the planning logic app, and there will be a definition parameter in there. You'll see the output will not be that nice, right? So take that into consideration, but you will get the actual the complete definition of this logic app, right? So let's actually try to see if we can make some sense of this output, right? What do we have over here? We have the parameters over there. We have some triggers, so we see some HTTP trigger, post request. And here we have some of the actual actions, right? And what we see in the workflow itself is a trigger URL, right? But I just told you that you will not see the trigger URL with just read permissions in the definition, right? The trigger URL is not part of the definition of the workflow. So this means that this is a trigger URL for another logic app. Right? So this, if we call this logic app, it will probably execute some other logic app, right? But since we have access to that, we may be able to just trigger this URL manually, right? So that is what we will be doing later on, right? But if you don't want to just get a mess on your screen, there are a couple of things you can do to enumerate. I don't think this specifically will be in the lab manual, so you can note that down. So if you use this notation, you can list the path as value to count any keys, and what that will do is for each block that it returns, it will tell you some information like how much parameters are there. Currently, this logic app has 0 parameters. There is one trigger that's called manual, and there's one action that's called response, right? So there is this specific logic app. It doesn't seem that it can be well, the trigger is called manual. You will see that it is an HTTP trigger. It's just called manual, right? And there is one action that's named response. So not a lot of functionality in this logic app over here, right? You can actually see if that makes a little bit sense in the logic app designer. Sometimes you might not really be able to gain access to that, but just to show you guys what we enumerated. So we see one trigger, an HTTP trigger named manual, and there is also just one action response, right? So that seems to line up with what we see over here. All right, so there is one trigger, it's called manual, but it's an HTTP trigger. How do we actually retrieve that? So for that, we need the permissions that you saw previously, the one to list the callback URL, and then we can use the get easy logic app trigger callback URL using the name of the logic app, right, and the trigger name, which is in this case called manual. If we do that, we will get the actual trigger URI of this specific logic app, right? So if we want to execute that, we saw that we need a post request, right? So any post request will do. We can do that from the command line if we just copy this value and use invoke REST methods with the post request. We will see that we will be able to trigger the specific logic app. And the response that we receive is a little bit weird. It seems like it returns a definition of, or some type of obfuscated definition of a different logic app. Right? And it also contains the trigger URL as we saw over there. Right? So is this something that you might encounter in a real scenario? Probably not, but it's just to teach you guys how to interact with that. As you can see over here, it's just a static response that is configured over here in the body. This is what it will respond, just to get yourself, make yourself a little bit convenient with how logic apps work, right? And then once we know how logic apps work, we will actually look at this logic app where we don't really have that much visibility on, right? So we have some type of visibility of the definition, but it is a little bit redacted, right? If we go through that, we will see there is also an HTTP trigger for this other logic app, right? And there are parameters, right? So this one can be triggered using a GET request. And after the trigger URI, we will provide a parameter, right? There are a couple of actions that will be executed. So there seems like there is a switch case at the top, and then it will, depending on the input it received, what input, if we see down here, you see the expression of the switch case is actually based on the parameter of the logic app, so on the trigger URI. Right? So based on which parameter we use to trigger this logic app, it will send some different responses, right? So there is one case if it is called, this is a default case, I believe. No, here it is. It's always a little hard to find how the JSON is structured. JSON is structured, right? So if the parameter is display, it will return response 1, right? We don't really know what's in there. Here it's just detected. Maybe this is some kind of definition they used to test the logic app, right? And maybe after that they modified that, right? So it will return response 1 if we send display command. If we send the execute parameter, it will send a different HTTP response 2. And by default, if you use anything else, it will just respond with a default response, right? So this seems to be what this second logic app will be doing, right? So let's actually trigger the default condition first and see what it responds with, right? So we have the trigger URI, right? Where did we find this? Over here, right? You see the action over there. This is where we want our parameter to be defined. And what parameter will we use? We'll just use default. We can use anything, but by default, if it's not display or not execute, it will just perform the default action, right? So let's execute that and see what response we get. It says the default action of optimization logic app is triggered. There's nothing to see here, right? So as expected by default, it will not do much, right? So let's actually use the second parameter to see what the other one does. Oh, didn't want to do that. Second one was display, right? So let's do display, and if we use display, it seems to return credentials of a user, which might be useful later on, right? So let's copy those. Okay. There's one more that we want to check, and that's the execute one. Let's see what this does. It seems to take some more time, so probably doing something in the background. Some more credentials, but this time it took a little bit longer, right? So it seems like also based on the parameter name execute that it executed some code to maybe create this user, right? This was fairly fast, so it's probably a static response, right? Here, these users are, these credentials are probably for users that are generated, right? So you have two credentials, one for Tony and one for simulation user, right? Let's also copy these for use later on. And it also says you can use these credentials to access the reservoir management app on this specific URL. Awesome. So let's do that later on, but maybe let's just first look at the credentials of Tony, right? So let's try to authenticate as the Tony user. So we take his password and his email address, and when we try to connect, it says you must use multi-factor authentication to access the tenant or provide the tenant ID. You can try with the tenant ID as well, but it will just give the same error message, right? We must use multi-factor authentication, right? So seems like we can't access that because multi-factor authentication is blocking us, right? In a real scenario, you would probably check if we could, for instance, bypass the conditional access policies by accessing some other resources, right? Maybe it is blocked for accessing the Azure ARM API, but maybe we can still access Maxwell Graph or something else, right? Maybe you can access some Office applications. Here we will not do that because we know that that will not work, right? All the resources will require multi-factor authentication for the user Tony. So why is this in here? It's just to show that multi-factor authentication is actually very strong. It does block attacks, right? It's not flawless, but in a lot of cases. Let me mute you. Let me quick. All right. Yeah, exactly. So a comment from John is that on the 15th of October, which was last week, Microsoft is enforcing multi-factor authentication, or when you try to access Entra ID, right? So accessing Entra ID as an administrator will now always require multi-factor authentication, right? But besides that, multi-factor authentication was already blocked for this specific user, right? Using a conditional access policy. So the credentials of Tony will not really work, right? Let's try the credentials of the other user, the simulation user, right? So let's try that. And we also get an error message. You must use multi-factor authentication, right? Actually, let's use the credentials of this user because that was the user that I used previously. Let me quickly copy the new credentials. And if we execute that, we get a different error message, right? So it still says authentication failed because multi-factor authentication is required, but always take note of what the error message is trying to tell you, right? So here it says multi-factor authentication is required. However, you must enroll in multi-factor authentication. You will specifically get this error message if the user doesn't really have multi-factor authentication enabled yet. So even if you do during a penetration test, do password spray on all usernames in the organizations, right? You might see on some accounts you will get this error message stating that multi-factor authentication is blocking you, right? So you won't be able to get access to that. But if you get this error message, you must enroll in multi-factor authentication. That means that the user should use multi-factor authentication, but it hasn't set it up yet, right? And this basically allows you to do something else, right? Because by default, you will then be able to create a multi-factor authentication method as the user itself. So this is, I see this very often, right, where the organization thinks all their accounts are protected because they are enforcing multi-factor authentication everywhere, but they have some old accounts or some accounts of users that left the company and they had not set up multi-factor authentication yet and they forgot to block them, right? And no one has ever set up multi-factor authentication on that, right? So let's show you what you can do with that, right? It also says over here, remember that we can use these credentials to access reservoir management app. Right? So here, because the user is newly created, no one has ever set up multi-factor authentication on that yet, right? So let's go to that reservoir management app in our browser. Let's try to sign in with the credentials of the user. All right. Let's do that. And you will see that it will prompt us for some more information, right? So you will usually get that if you need to set up multi-factor authentication. So let's do that. Now I need to be really quick to ensure that none of you guys are gonna be enrolling multi-factor authentication on that. It won't really matter, right? Because it's just user credentials, right? For the lab credentials, you will be able to do this yourself as well. In the lab with your own account. Seems to be taking some time. Let's continue. All right. Can we use the time-based one-time password to share the multi-factor authentication? For the Microsoft Authenticator app, I don't think that is possible. However, if you click over here on I want to set up a different method and you select a different Authenticator app, there it will just use a secret key, and based on that secret key, it will generate the TOTP code, and that you can probably share in multiple locations, right? But the Microsoft Authenticator app is a little bit more complex with the number matching that you need to do, so that would not be possible, I think. Yeah, if you use a third-party client, then it will be possible. All right, we've configured multi-factor authentication. Yeah, most password managers also allow you to put that in there, right? Okay, let's continue. So we're prompted for multi-factor authentication, right? Remember, we're still trying to sign in to the reservoir management app, and now we seem to get some error message. It says that the simulation user from the identity provider does not exist in the All Corporation reservoir, right? So this user is from All Corporation, and it does not exist in All Corporation reservoir, so it cannot access this application reservoir guest registration, right? The account needs to be added as an external user first, sign out and sign in with a different user that can access this. So this error message, basically, yeah, it tells you that only users from reservoir tenant can access that. However, if we look reservoir guest registration, this gives us some idea of what is happening in the background, and this application actually allows self-service sign up, meaning that any user can sign up for this application using their credentials, and that will create a guest account in the tenant automatically. Right. How can we enumerate that? Well, here we assume it because the application is called reservoir guest registration. There's no real way to actually know that other than trying that from an authenticated perspective. However, you can, if you have access to the tenant already, you can find that out. So I will show that later on, or actually, let me show you that right now, right? I mean, the right tenants. Let's go to the cross-tenant access settings. So to come back a little bit on the content from the previous session, you will see that in All Corporation there are some cross-tenant settings configured for the reservoir tenant, for the All Corporation reservoir tenant, right? So the organizational settings, remember, they will override the default settings, right? And we see inbound access is still default, however, outbound access is modified. So let's see what is modified over here. We see that outbound access, so in B2B collaboration, outbound access is allowed, however, only for specific users. That means that users from this group, the simulation group, which you can already guess, our simulation user will be part of the simulation group. So this users in this group will be able to access the tenant, right? these are all default. Trust settings. Here, automatic redemption is set up, so meaning that consent prompts will be overruled, right? So there will not be any consent prompts. However, we can't really access it still, right? So let's look at the settings in all corporation reservoir really quickly. Let's change tenants really quickly. No. Let's now see the same cross tenant access settings from the perspective of the reservoir tenant. We have some inbound organizational settings that are configured, right? So here the outbounds are still at default, but inbound they are changed, right? So inbound it says from the well, actually maybe I should have shown you. This is the all corporation tenant, right? So inbound access from the all corporation tenant is also allowed from select users in all corporation. Right? So these are is the same group, but in all corporation it can't really resolve that. But this is the ID of that group that you saw, right? Direct connect is still default. Trust settings, so trust multi-factor authentication from the other tenant, right? And there is no cross-tenant sync, right? But you might be thinking over here, why is this required? Because by default, remember the default settings for inbound for B2B collaboration was to allow that, right? But if you see in the default settings for inbound access, were modified in this tenant. Oh, didn't mean to click on that. You will see that B2B collaboration inbound will be blocked by default, right? So don't get this confused. This is called default settings, but you can change the default settings, right? So by default, no one can be invited as a guest using B2B collaboration to the reservoir tenant. However, it is overruled over here for all corporation, meaning that these users will be able to gain access to that, right? All right. Anything else I want to show you over here on the tenant? I don't think so. So how can we actually gain access to this tenant right now, right? We will show you. So if we go back to sign in with Microsoft, actually let's close that because we don't want it to automatically sign in. So let's go back to application without being signed in. And instead of filling in the credentials over here, you will see there will be an option here, no account, create one. Right? So create one where in the reservoir tenant, right? So that is where we are connecting to. This is the tenant ID of the reservoir tenant, right? Create one. So you can sign up with an email address. If it would not have been restricted, anyone would have been able to create this guest account over here, right? Because it is restricted to users from the whole corporation tenant and only users from the simulations group, only these users will be able to do that, right? So we can do that, take our passwords previously. And our multi-factor authentication is already set up. Let's see if I get a notification. Come on. Doesn't want to give me a notification. Let's do it again. Okay, there we go. Now we have it. right? Actually, this is my bad. Let's do that again because we should have received a pop-up, but I was using an account that was already created. No, not over there. Let's log in with the other simulation user that we just created. There's one thing that I want to show you during the sign-in process using the newly created account. No, did it go wrong again? Let's go back. I need to click on I needed to click on the create user. Right. Okay, this is what I wanted to show you guys. So this will indicate that you are creating an account in the target tenant, right? It's requesting some information, so some profile information from your home tenant, right? And there is a link to their terms of service. If you accept that, now in the background, it will create your user in the reservoir tenant, right? So you can just click continue over here. And sign in. And now we get access to the application, right? Question is it best practice to modify the default cross-tenant access settings to disabled and then to open it as required? So best practice, I think that would be a good thing to do, right? By default, the guest registration automatically will not work. You will need another setting for that, right? So, but doing so, changing the default cross-tenant access settings will, and only including the tenants of the partners you work with, who needs guests in your organization or which your organization needs to have guest access to other tenants, right? It is a little bit more overhead, but it will prevent users from randomly inviting anyone into your tenant, right? But you also have other settings for that, right? You can also restrict normal users from inviting anyone from other tenants. But if you do want to allow users to invite users from other tenants, you might want to restrict from which tenant they are allowed to invite these users, right? If that makes sense. So what happened over here? We got access to the reservoir management application. Nothing really very special over here, right? You can go through that, but you won't really see anything special. But if we now go to the Azure portal, we will see that if we click switch directory, that we have access to the reservoir tenant because our guest account got created there due to the self-service sign-up. Awesome. And let's see if we have some access to see some information in Enter ID. Seems like we can also list users and other things. Anyone seeing anything weird over here? A comment is not everything, because you will not get invited to the tenant or user external resource from your tenant to another tenant. Don't really know what you mean with that, John. However, a normal user should not have this much access. A guest user by default does not have this much access in the other tenant, right? However, here settings are configured to allow guest users to have the same kind of access as a normal user, right? So by default, it will be this one: guest users have limited access to properties and memberships of directory objects, so then you will not be able to see all the properties as we're listing now. But here it is set to allow guest users to have the same access by default as normal members, right? Is this something that you should take into consideration? Is this secure? Well, in this specific case, it can be, because remember the collaboration settings are very, very restricted, right? Only users from the old corporation tenant will be able to gain access to this tenant as a guest, and only specific users for a specific group, right? So in that specific use case, it would be fine, right? If these users need that kind of access in the tenant. It's an on-prem joint domain. This one, it will also be joint. Yeah, we will see that later on. All right. So let's look at the chain diagram where we are. Yeah, indeed, by default, John, users from other tenants will not be able to gain access to this tenant, indeed, right? Only allowed for the old corporation tenant. Right? Users from that old corporation tenant will be able to gain access there. All other users from other tenants will not be allowed due to the B2B collaboration settings, right? All right. So what did we do? This was the end of learning objective 7, where we went through. Right. So we read, as the well planner user, we read the configuration of the well planning logic app. We triggered that logic app as well, right? Which gave us the definition of a second logic app, which is called optimization logic app, right? We were able to trigger this logic app as well. We saw that there were 3 conditions based on a parameter. By default, it would just return a generic message, which is not really that useful for us. However, if you provide the display parameter, it will provide the credentials of a user, but that user requires multi-factor authentication, so we can't do anything with that. But the execute parameter triggered a function app in the background that created the simulation user X, right? And since this user was just newly created, multi-factor authentication was not enrolled already, so we could enroll multi-factor authentication ourselves. And with that user, we could access the reservoir management app, right? And this was in the reservoir tenant, right? But because of the configuration, self-service sign up for this application was allowed, allowing the simulation user to invite itself basically in the guest tenant as a guest user in the reservoir tenant, right? So you could access the reservoir tenant with this user. And later on, we will also see that this user will have some specific permissions, right? So this will be what we will be focusing on in the next learning objective, right? Let's go back to the PowerPoint. Awesome. Microsoft Entra Cloud Sync. So we will see later on, as a question that was asked, this is an on-prem joint domain. yes, it is a hybrid tenant. There will be some hybrid users in there as well, right? So you are probably already aware of AAD Connect, right? Azure AD Connect, but Microsoft released a new kind of Connect option, which is Microsoft Entra Cloud Sync, right? And this one is actually intended to be a little bit more secure than Azure AD Connect, right? It has a little bit the same functionality, or almost all the same functionality. We'll cover some of the differences later on. Azure AD Connect was covered in the basic class, right? But Entra Cloud Sync is intended to be a little bit more secure. It still has its flaws, but we will see that it is indeed a little bit more secure, but there are still some things that we can do with it, right? So Cloud Sync is an alternative to Connect Sync or Azure AD Connect. Right? Sometimes Microsoft calls it Cloud Sync, Connect Sync in their documentation to get a hybrid identity. Cloud Sync supports password hash synchronization, just like AD Connect, as well as federation for hybrid identities. However, there's one option that is missing. Anyone knows which one? So you have password hash sync and federation. Indeed, pass-through authentication is not supported. So pass-through authentication is not supported over here because the idea of Microsoft with Cloud Sync is that instead of putting the on-prem environment in control with Entra Cloud Sync, it's actually the cloud environment, the Entra ID that will be in control, right? Do many organizations use pass-through authentication? Is a question that's being asked. Not that much, right? It is used. It is used regularly, but usually they just use password hash sync. It's easy to set up and it gets the job done, right? But there are organizations using that, right? All right. So it works a little bit the same. There will be a provisioning agent on-prem. It can be this agent can be configured on your domain controller, and you will see that a lot of organizations will do that. Or it's not required. It just needs to be in a server on-prem, right? And it needs to be able to get access to your domain controller, right? It needs line of sight of your domain controller. It doesn't need to be on your domain controller itself, right? Are they planning on adding pass-through authentication support to Cloud Sync later on? I don't think so. Because you will see, well, I really think that they will not do that, right? Maybe Microsoft can, if enough customers ask for that, but I don't think so, because some other questions popping up. So we know that is not the default configuration, right? So its default B2B collaboration settings are to allow access inbound and outbound. Okay, so how does Entra Cloud Sync work? Right, so obviously Entra Cloud Sync, the Entra cannot directly communicate with the provisioning agent that's on-prem somewhere directly, right? You don't need to open a port or open a port on the internet. That would not be that secure. So it works by the connect or the provisioning agent that's on some servers on-prem. It can be on your domain controller. It doesn't need to be. This one will periodically pull Entra ID's provisioning service, right, using System for Cross-Domain Identity Management requests. So SCIM requests is a standard that it will be using, right? So it will send these requests regularly to Entra ID, right? And it will see if there is something in the queue, right? Entra ID provisioning service will have a queue on there and will respond to the requests from the provisioning agent with actions that it will need to take, right? And the provisioning agent will then execute these actions. For instance, it will send some queries to Active Directory. Active Directory will return the results to the agent, and the agent will then respond with the answers that the provisioning agent was looking for, right? Using the cross-domain identity management response, right? And then the provisioning service will write any changes to Entra ID. The question is, what is the advantage of Cloud Sync in comparison with Entra Connect? Most of my customers have Entra Connect in on-premise. Thanks. So security benefits, it's mostly security indeed. So what's the advantage? The biggest advantage will be security. We'll see later on why. Right. So if you look at the abuse cases that you have, on the provisioning agent, there will be, or on your on-prem domain, there will be a GMSA, a group managed service account, or sometimes referred to in Microsoft documentation, a general managed service account. Right, that's all over the place with their terminology. But this account will be named PGMSA and then the installation ID, right? So a little bit of security benefits from this already, because AD Connect didn't use a group managed service account, right? So benefit of this is that the password of this account will automatically reset every 30 days, right? And it will be automatically set to a secure password that will be rotated automatically by your domain controller, right? So this is the account that is created on-premise, and there is also an account that is created in Entra ID. It's called the AD to AD sync service account, right? On-premise directory synchronization service account is the display name. This will be in Entra ID. Right. If password hash sync is used, then this account, the PGMSA account, will have replication rights to the forest that is synced to. So one abuse case that we already see over here is if you compromise the server where AD Connect is running on, you will be able to get the passwords of the PGMSA account, right, and use that to perform a DC sync. Similarly, like we are able to do with AD Connect, right? So this is still possible, right? However, what is not possible is to obtain the passwords of the AD to AD sync service account. Remember with AD Connect, there was a sync account. This was the sync account was stored in Entra ID, and the password of the sync account was also stored on the AD Connect agent, right? And you could extract that, and that account was able to reset the passwords of all Entra ID users, even of the global admins and the account owners. So if you would compromise that, you would compromise the complete domain, right? Later on, they fixed that a little bit to ensure that you would only be able to reset the passwords of hybrid users, right? But still, that is a security issue because you don't have that anymore. The password of the AD to AD sync service account is not stored anymore on the provisioning agent. So meaning if you compromise the provisioning agent, now the impact will be limited to a DC sync on-prem, right? So this is, to answer your question, why you would use Cloud Sync in favor of AD Connect, right? Cloud to on-prem lateral movement, there is still obviously some ways to abuse this. Let's say you compromise Entra ID and password writeback is enabled. So password writeback is still a feature that is supported, right? And basically that allows you, or that allows users, if they reset their password and enter ID, password writeback will make sure that the password is also changed on-prem, right? So that they are not going out of sync, right? So if we compromise enter ID and password writeback is enabled for users, and we compromise some kind of account that has password reset permissions over synced users, we will be able to reset the password of a synced user that might have interesting privileges on premises, right? And then we will be able to use that on premise. Note that you still need to have some line of sight of the domain controller or need to have a foothold inside of the internal network, right? Otherwise, you will not be able to do much with that, right? But if you compromise enter ID and password writeback is enabled, and you can reset the password of a synced user, that password will also be synced on-prem, and you will be able to access that account on-prem. Right? If it has interesting permissions on-prem, that could allow you to do some privilege escalation if you already have footholds on-prem, right? However, do note that the default security groups are not synchronized, which means that domain administrators are by default not synced to the cloud. If you really want to, you can probably achieve that, but by default, that will not be the case, right? And all other users with the admin account property on-prem set to true as well will also not be synced by default. Right? In the lab, you will see that there is an enter ID group called organizational units admin sync, right? And we have user administrator role in that to reset the password of some synced users. We'll see that later on in the learning objective. This slide basically explains the same that as I already did. If you compromise the provisioning agent, you will be able to use its credentials of the PGMSA account, which you can get from compromising the computer account on which the provisioning agent is running. The computer account of the server where the provisioning agent is running will be able to read the PGMSA account its password, right? That's how group managed service accounts work, right? So if you compromise the provisioning agent server, you will be able to perform ADC sync attack, right? Only if password hash sync is enabled. Otherwise, this account will not have the privileges, will not have replication privileges, right? So it will not be able to do a DC sync attack, right? Also note that by default, group managed service accounts, their passwords are rotated every 30 days, meaning that the time frame you have for persistence will be a lot shorter, right? Previously, if you compromise the credentials of this account, you would be able to infinitely perform DC sync attacks until they would rotate that password manually, right? Which was a struggle to do, right? Now it will be automatically rotated, meaning that to keep your persistence, you would need to keep your persistence on the provisioning agents itself. So if you are able to keep your footholds on the provisioning agent or the machine account of the server where the provisioning agent is running, you will be able to keep requesting the password hash of the PGMSA account, right? But at that point in time, it might be easier to use some other attacks for persistence, right? All right. So, learning objective 9. Let's first, before we do that, show you some stuff in the Azure portal, right? Where we are over here. Actually, let's not use the simulation user because it might not have all the privileges we need. If we go to Microsoft Entra Connect, so it's still at the same location. You will see that there will be Connect Sync. If you click on that, you will see that password hashing is enabled over here, right? If you go to Cloud Sync, under the configuration, you will see that there is some cloud synchronization setup. So Cloud Sync is used with the Reservoir One corporation, right? So both to from Microsoft Entra ID to AD and the other way around, right? So how can we enumerate whether Connect Sync or Cloud Sync is in use? As a low privilege user, that would be a little harder to do from here, but there are still some options, right? There are some indicators that you can search for, right? If we go to Entra ID, and here this we can do with our guest user or simulation user in the tenant. If we go to the users, there are a couple of things we can look for. Obviously, over here, there are just a lot of users that are called hybrid user. But let's say we want to be a little bit more precise, we can search, for example, for the AD to AD sync service account. If this exists, this is an indicator that Connect Sync is used, right? No, not Connect Sync. Enter Cloud Sync. For Connect Sync, so AD Connect, there will be a user called sync underscore something, which is not the case over here, right? What else can we look at? If we add a filter over here and list all the accounts with on-premise sync enabled, we will see that there are some accounts that are synced to on-premise, right? Some other indicators on these users, you will see if you go to their properties, there will be a couple of attributes on there that will indicate that synchronization is enabled. We'll see, for instance, here the on-prem security identifier. So this will be the set of the domain and the set of the complete user as well. Right? So all of these properties will not be there if the user is not synced. All right. So with that, let's look at the learning objective. Right. So learning objective 9. A simulation user X reset the password of hybrid user X in the all corporation reservoir tenant. Okay, so let's use to that. We have not really enumerated the privileges of the simulation user just yet. However, we can go check our own role assignments. You can click over here on view role information. Let's wait until this loads. And we see that we have an active assignment for the user administrator role, right? Scoped to complete directory, meaning that the simulation user can reset the passwords of anyone in the all corporation reservoir tenant, right? Or yeah, everyone is maybe set a little bit too much. It will be able to reset the passwords of regular non-administrator users, like not reset the password of the global admin, otherwise that would allow privilege escalation, right? So let's go look at the users that there are. There are not that many users in here. Well, there are a lot of users in here, but all of them are called hybrid user. And so there will be a hybrid user for every student. So let's look for hybrid user 6. user admin cannot reset password for admin in cloud. No, exactly, that's what I said. So comment is about the security benefits between Interconnect and CloudSync, saying that if you are able to seal the password of the GMSA account, you can still perform the same type of attacks as an AD Connect. Yes, exactly, you can. That's what we looked at, right? However, it will be limited, right? So if you steal the password of the PGMSA account, you will be able to desync on premise. However, it will automatically rotate every 30 days, right? So the time frame which you can keep on using that for persistence is reduced. Additionally, you will not be able to gain the credentials, extract the credentials of the AD to AD sync service account, right? Which with AD Connect you would be able to do, meaning that you could not only compromise on-premise, but you could also compromise or reset the passwords of users in the cloud, right? Question is, can the user admin reset the password for admins who did not do PIM yet? Technical, not an admin. You mean that they are eligible to enable, for instance, global administrator, but they are not actively a global administrator? Interesting question, but I would assume that will not be possible. Right? Otherwise, that would also provide privilege escalation paths. Right? So I'm pretty sure that will not work. I assume, or I hope at least, that Microsoft took that into consideration. But I've not tested that, so it's interesting thinking of you. I'm 90% sure that that will not be possible. Okay. Okay, with that, let's look at the learning objective. So we saw that we were able, we go to the users, there will be a hybrid user for every student. So for me, it will be hybrid user 6. So if we go over there with our user administrator rights, we will be able to reset the password of this user, right? And since this user is synced to on-prem, which you can see over here, on-premise sync, yes, we'll be able to reset its password and potentially use that to pivot to on-prem, right? So let's reset the password of that user. Thank you for sharing that. Lipao. Awesome. So we reset the password of the hybrid user 6 account. And now we should be able to sign in with that account, right? So a couple of assumptions to make over here. Since this is a course where we focus on entirely cloud, we will not focus on how you would have already obtained a foothold inside of your target organization. But over here, you will see that the student users will already have some line of sight to a domain controller, right? So what this would allow us to do is to create a, actually, we'll start in new command prompt as an administrator. And over here, we'll use run as with the credentials of the hybrid user 6 to spawn a command prompt in the with the context, with the rights of the hybrid user 6. So we are using a net-only command prompt, meaning that this will be a local type 9, so it will not provide us local access on this account, but when it uses network connections, it will use the privileges of the hybrid user 6. So let's do that, and let's provide the password of this user that we just reset. All right. So you will not know whether the credentials are correct, right? It will always spawn the session because at this point it has not authenticated anywhere yet, right? But if we would try to authenticate to anything on the network, you will see that it would use the credential of that user, right? So how can we validate that the credentials are correct? We can, for instance, try to connect the domain controller and custom information. Let's use a VisiShell to do some local evasion. Is not really required. We can also just disable Defender because this is an attacker machine, but just for the sake of it, let's run PowerShell and invoke import PowerView. Right. So we're going to do a little bit of on-prem AD enumeration. That said, we'll not focus on this too much. But what you can do, for instance, with PowerView, for those that have taken the CRTP or the CRTE courses, you'll probably already know this, but we will be able to enumerate some information from the on-prem domain controllers, right? So in this case, we will be listing all the domain computer accounts from this domain controller that we would have already enumerated in a real assessment, right? So we're gonna list all computer accounts. And since we get output, this indicates that the credentials that we provided previously are actually correct, right? Otherwise, we would not be able to get an access denied, right? So what do we have over here? We have, we see the reservoir 1 domain controller. We see the PG-MSA account, right? So the provisioning agent, right? Will always be there as a computer account because it's a group managed service account, right? These will take the form of a computer account. We have the reservoir user, computer, and the Azure AD rows that will be used for something later on. But this was just to confirm that our credentials were valid. In this case, what would you do if you are in this scenario? You would probably run something like Bloodhound or whatever, enumerate all the privileges you have and see what you can do. Since this is a lab and we don't want to focus too much on on-premise enumeration stuff, we will just automatically or instantly check if we have replication rights, right? Because in this case, we will already know. So with the command that we executed over here, what are we looking for? We are listing all ACLs, all domain ACLs on the reservoir 1 domain, right? And checking if we have which users have a replication, right? So DC sync rights over the domain, right? And then we will list all the users that have that. So DC sync rights over generic all, right? And if we do that, we see that all the hybrid users will have the extended replication rights, meaning that these users will be able to do DC syncs, right? Will you get to a point where you will be able to do this quickly in a real assessment? Probably not. You would need to do some enumeration, see which users are synced to the cloud and which users have higher privileges on-prem. So you will probably pick some targeted account where you know that that user will already have some higher privileges. Right, reset the password of that account and then abuse that, for instance, to perform a DC sync attack in this case. Question is, can this attack apply to taking advantage of the server listed in the Azure's logon server contained in system info? I'm not really sure what you mean with that. Let me talk. If you could clarify. In the meanwhile, let's actually, so we know that DC Sync is enabled over here. So let's perform a DC Sync attack, right? So DC Sync is basically the abusing the protocol that domain controllers use to keep information about their domain in sync, right? So multiple domain controllers always need to have the same information on their AD database, right? So it will sync the information of all users, including the password hashes of all users, right? So this is what we abuse using the DC Sync attack, right? So let's spawn a PowerShell or a command prompt process and use argsplit. So this is basically a tool from the basic class from the CRTP as well. It's just to perform some evasion because you will see that we will be running mimikatz commands, right? So as they dump DC sync, this might be something that is detected by a normal EDR or by a normal antivirus can probably detect that, right? So it will just take a string and obfuscate that a little bit, and then we can it will provide us with some commands to execute. We'll just copy that and execute that, and then you will see that the variable tone will contain our commands, right? So then we can use that later on in our next commands, right? So what are we doing with the next command? We are using the loader program to load the safety cat. So a version of mimikatz that's a little bit more obfuscated. We run that directly in memory with the command dump DC sync will be replaced over here, and we will perform a DC sync of the administrator account, right, on this domain controller in this tenant. Alright, so if we do the DC sync attack, we will see that mimikatz will return us all of the output. So it will dump all of the password hashes and all the secrets for the domain administrator user, right? So now basically we can do anything in domain that we want. We have completely compromised that domain because we can do, for instance, a passage attack, or with the AES keys, we can do an overpassage attack, right? So, going back on that question, I go log on server. I don't think this is really applicable over here. This student VM will not be joined to the on-prem domain, right? So a question is regarding the DC sync attack. Why is it that Microsoft continues to fail to catch the string reversal trick? Has this technique existed forever? Do I expect it to continue forever? No, probably not. A better EDR will probably catch that as well. It's just to provide you some insights on what techniques that you can use. It will definitely not work against a decent EDR, right? So here we are just using the free Windows Defender, right? So there it might work or might not work in the future, right? However, this is not a course based on where we want to go very deep into evasion, right? So that's why we will keep this a little bit limited, right? But usually, if you perform that attack from an attacker-controlled device, you don't need to worry about EDRs on your own system, right? This is a completely remote attack, right? So you might be able to do this from your attacker machine. So then you don't need to do any evasion. Okay, so let's continue. We have the password hash of the domain administrator, right? So what can we do now? Let's actually do the same sync attack and show you. You can also obtain the information from other domain accounts, right? For instance, the PG-MSA account. We can list its password hash as well. Right, so here we have that. So if we have that, we can also perform DC sync attacks with this password hash right now. Now we don't really need it because we already have DC sync accounts on DC sync rights on our student user, right? But you might get into a scenario where you can compromise the computer account or the where the connect service is running, and then you can compromise these credentials and also perform DC sync attacks with that. Right. Okay. Let's exit this session. Okay, we have compromised this reservoir 1 domain fairly quickly, right, as intended. But let's see if there are some domain trusts. Right, so it seems that the reservoir 1 domain or forest is trusting a different forest, right? Or it's actually the other way around. The reservoir 2 forest trusts the reservoir 1 forest, right? So we have an inbound trust. So some other forest is trusting the forest that we have just compromised, meaning that the direction of access will be the other way around, right? Because this forest trusts us, meaning that we can access the other forest, right? So users in reservoir 1 will have access to some resources in reservoir 2. Note that this is a forest trust, right? So meaning a cross-forest trust will only by default have access to resources that are explicitly shared, right? So we will not have access to everything, but since a forest trust is created, that would indicate that there is probably some resource that we would be able to access in that tenant, right? If not, why would this trust exist, right? Okay. So let's actually see what we can do with that. So we know that there is a trust. Let's quickly do something else. So this command, we execute that to basically, because later on we will be doing we will be using WinLM. So we will be using some partial remoting, right? But partial remoting will not work from a non-domain joined device to a domain device by default. It will not allow you to connect to that. Here you're basically saying allow connections outbound to all hosts. Everyone a wildcard, everyone is trusted. We want to connect to it. We want to be able to connect to every other system using WinLM. That's why we do that. Right. So let's go back to our original administrator command prompt. And now that we have the credentials of the domain administrator, let's see if we can do anything with that. Right, we're going to perform an overpass dash attack. Right, but for that we will once again use mimicots. So we will do some obfuscation first, right? So we will be using the overpass dash command from mimicots. Let's obfuscate that. Right, so let's check if our variable was configured correctly. So it seems to be the case. And now we can perform an overpass hash attack. Right. What does that mean? It means that we will be using the credentials of the password hash of the administrator account. Where did we get that from? Using the DC sync attack over here. Right, if I scroll up a little bit, you will see the password hash of the domain administrator will be 348BC, which is this one, right? So we can use that directly to authenticate as this user using an overpass hash attack. So we will spawn a command prompt, once again using log on type 9. Why are we using this and not the runes? Because runes does not accept a password hash, it only accepts a password, right? But it will have the same effect, right? So now we get a different command prompt, and this command prompt is running as the administrator, domain administrator user, basically. Let's increase that a little bit for you guys. Okay. So we can now try to connect to the domain controller. of reservoir 1, right? Let's do that. And we see that this works correctly, right? So this is using PowerShell remoting using WinRes. We can now execute commands on the domain controller as, who am I? Who am I? Wow. So we are the domain administrator, right? On the reservoir 1 domain controller, right? So we are still in the first domain, right? So we know that there is a trust with another domain, with another forest actually, right? With reservoir 2, but we don't know where the domain controller is yet. So let's enumerate that, because we now want to get access to that other domain, or that other domain controller, right? In the other forest. So we can check, for instance, if there is an IP address in the DNS server zone for reservoir 2, and it seems that this will be the case. So we see here the IP address of reservoir 2, right? Meaning that this will probably be the domain controller. How else can we find that? If we do let's lookup of reservoir 2, it will give you the IP address of the domain controller. But if you want to go a little step further, it is also not in the lab manual. But a quick trick I can show you guys. So if we use ls lookup to set the DNS server to the domain controller of the other domain, right? The domain controller of reservoir 2, you can now query it to list all its domain controllers, right? Maybe there are other ones, right? We will set the type of DNS records that we will query to all. Then we can basically use this query LWTCP DC MSDCS and then the name of the domain. Right. This is a record that will exist on all the domain controllers, and it will return for you all of the domain controllers. Here it's only one. You already knew that it was this one, but it will also list the host name now. Right. So we see that there is a domain controller named reservoir2 DC with this IP address, right? If there were more, it would list all the domain controllers, right? So quick trick for you guys. This works unauthenticated, right? So if you don't have privileges yet in your target domain, you can use this DNS query to list all the domain controllers without using any authentication. Right, so why am I showing you that? Because we will need to create some records in our host file, right? Because otherwise we will not be able to connect to that using host names. Right, so let's modify our host file and add the IP address of reservoir 2 in there, also known as the domain controller over there. Right. The only reason that we were able to connect to the previous domain controller already is because the student VMs will already have this record configured in the host file. Right. Awesome. Let's exit over here and exit over here. So we're back on our own machine. How else could we have enumerated domain controllers? If you have already credentials, you should be able to use something like this in the Power View. So this will also only work because now we have added the host entries over there. But just to confirm that we will be able to connect to the domain controller in the other domain, right? Let's do that and see if there are any other domain controllers, right? So we get some output, meaning that we are able to access that domain controller right now. We also see, it will also list all of the domain controllers, right? There is only one in this case, so not that much to find, but just to confirm that we have the access, right? Okay, so as I said, in a cross-forest trust, you will only get access to explicitly shared resources, right? Meaning that users in reservoir 1 will explicitly be needed to be provided access over some resources in reservoir 2, otherwise it wouldn't work, right? But in this specific case, yeah, if there is a forest trust, there will always be some type of access, right? It might take very long for you to actually enumerate that, but there will be a reason why it is there, right? Here, the domain administrator of Reservoir 1 will have received some access over a file share in Reservoir 2 on the domain controller Reservoir 2. So let's enumerate the file shares on the domain controller of Reservoir 2 as the administrator of Reservoir 1. Right? And we see that there are some shares. So sysvol netlog 1, we probably know these are default shares. This one, not so much default, right? Shares with Reservoir 1, also a good indicator over here for lab purposes as well, a very easy to find name. So we see that this will probably be accessible from Reservoir 1, right? Let's list the contents of this file share on the domain controller. If you use there to just list the contents of this shares with Reservoir 1 SMB share, you'll see that there will be a file in there named flag2.txt, right? And this will be the final flag for Killchain 2. Right? I will not list that. That will be something for you to do, but you can submit that to the web portal, right, to get the final flag. Awesome. So let's see where we are. So the simulation user admin, so the simulation user over here was part of this group, which is user administrator role over the CloudSync organizational unit, or over everything actually, and it contains the hybrid user X. Right, so we reset the password of this user, gained access on-prem using CloudSync. Right, we found that the user had DC sync rights on-prem, right? So from the DC sync attack, then we, with the DC sync, we got the password of the administrator user, which had access to a file share in Reservoir 2, right? Because there was a forest trust with Reservoir 2, and there we got the final flag. All right. So really quickly, before we take a break, I want to show you one more thing. So let's go back to this command prompt where we are signed in as hybrid user 6. Right. Let's use the R split again to perform another DC sync. And here, I'll run through this really quickly. So let's say dump DC sync. Okay. So what we can do is perform a DC sync attack over the Reservoir 1 DC computer account. So this, in this case, this is a domain controller, but this is also the server where the provisioning agent is installed, right? Meaning that this account will be able to read the password of the provisioning agent of the PGMSA account, right? In a normal scenario, you might compromise this account through something else, right? Here we're using a DC sync because we have that. You can compromise this computer using anything you want. In this case, it's already a domain controller. It could be another server, right? So let's say you compromise the server. How can you get the password hash or the password of the PGMSA account, right? Without doing the DC sync. Let's say you don't have DC sync privileges, but you do have the password hash, or you have compromised the password hash of the server where it is running on. Right? So let's copy the password hash. And let's go back to our original command prompts. We have a lot of command prompts now, so I think it's this one. So let's run a command prompt use overpass the hash now using the password hash of the DC sync of the domain controller account. Right. Once again, we get the command prompt. This is running with the privileges of the domain controller computer account. Once again, it's a little bit of a weird example because it's already a domain controller, so you can do quite a lot of other attacks, but it doesn't always have to be a domain controller, right? what we can do is once again run invisi shell to do some obfuscation, and let's import the Active Directory module, the Active Directory PowerShell module. So if we enumerate all the group managed service accounts with the get AD service account command, we will see that there will be one GMSA account, so this will be the PGMSA account. So there's one managed service account in the domain, one group managed service account in the domain, right, as we already knew. So how can we get the clear text password of this user? Right, using the get AD service account, so the same that's we performed previously, but now we are targeting this computer account or this group managed service account directly, right? And we are specifically requesting the managed passwords attribute, right? And then we will be listing that out. You will see that we will get that, and what will be in there. You will see that the passwords will be completely random, right? So it's quite long. It's just binary data. It's a non-readable password. It's very strong. You can't really type that in with normal ASCII letters, right? However, we can use a tool from DS internals to generate the NTLM hash, so the empty hash of that binary data. And obviously with an empty hash, we can do a little bit more, right? We can type that in a little bit easier, right? And now we would be able to go back and perform an overpass the hash attack with this PGMSA account and perform a DC sync attack once again, right? In case we wouldn't have DC sync privileges already, right? So that is how this would work. Is there a command that will show when the password of the sync account will automatically reset? A command that will show when it will reset. Not really sure. I can probably see when it was last reset. If I go back, where was it? I think over here. Right. So here, if we just list everything and go to the PGMSA account over here, you would see the last password change. If you can find it, when changed, it's not the one, last log on, password last set. So you can see it over here. So it was yesterday, right? So based on that, you will be able to calculate when the next password change will happen, right? Okay. So that was it for kill chain 2 actually. Right? So let's quickly take a 15-minute break. 15-minute break, right? And we will be back afterwards. All right. Any questions about the topics that we covered in the previous coaching? In that case, if there are no questions, we will start with coaching 3. Okay, so we'll keep this introduction about GitHub briefly, but most of you will probably already know what GitHub does, and that there are a lot of opportunities in there for an attacker to gain access to some sensitive information like secrets, credentials, and so forth, or if a user with commit rights is compromised, right, then we would be able to modify or send our own commit, right? And if there are servers that will automatically request or build these repositories and execute them, you might be able to get code execution over there, right? So a lot of things you can do with GitHub, right? And organizations creating their own or developing their own applications might use GitHub um, to collaborate and create their own software on there, right? And in a lot of cases, this might not be integrated with a single sign-on, for example, right? Using Entra ID authentication, right? So at best, it will just be username and password. And if you are lucky, they will also enable multi-factor authentication on that. But you can't really enforce that if you haven't integrated that with Entra ID authentication. And even if they have multi-factor authentication, it might not be enforcing conditional access policies, right? Like you have in Entra ID available and things like that. So we will use GitHub as an example over here. But the same is true for all other types of third-party applications that an organization regularly needs to allow their users to access, right? Some of these third-party applications don't support single sign-on using Entra ID, for instance, or they do, but it isn't set up, right? Some of third-party applications don't even still support multi-factor authentication, right? And if the application supports that, it may be sometimes even hard to enforce your users to use that, right? So a lot of opportunities for an attacker to gain access to that, right? What we will be looking at over here at the start of code chain 3 is at GitHub Actions, right? So GitHub Actions goes beyond just DevOps and lets you run workflows when other events happen in your repository. So to quote it directly from the documentation from GitHub, so it's basically you can think of it as a little bit like Logic Apps, but in GitHub, right? It's not completely correct, of course, but it will allow you to create some workflows just like Logic Apps do, right? So everywhere you see workflows, you can think of that as some kind of process that will let you automate stuff, right? In this case, GitHub is actually allowing you to use quite a lot of programming languages, so it's not really always that drag and drop like a Logic app would allow you to do, but you can configure a workflow to run when a specific event happens. So we will look at what these events can be later on. But for instance, if you have to give you one example, for instance, if there is an issue opened on a GitHub repository, that could be an event that would automatically trigger a workflow in the background, right? Maybe you want to automatically send an email to someone of your organization, to your developers, that an issue was created. Maybe a bad example, because you could do that with something else, but maybe you want to automatically create a ticket in your ticketing system, right? You can integrate all kinds of things with that as well. So it's basically a virtual machine that will be automatically executing your code that you have configured, and this can be a Linux, Windows, or macOS virtual machine. So the next one will be Ubuntu, I think. We will see that later on. And so some terminology about GitHub Actions. We have an event. So as I said, this is the actual action that triggers a workflow. So I gave an example with an issue being opened, but it could also be a pull request to automatically do some checks on the code, for instance. Right? It could be a commit. It could be even with a webhook like a REST API call, right? Or on a specific schedule. All of these could provide triggers, right? And in a lot of cases, if this on GitHub, for instance, in a lot of cases, if you allow that on a public repository, anyone might be able to trigger a workflow. For instance, like if an issue is opened and it will automatically do something in the background, then there you already have a tiny bit of privilege escalation because you don't really have any privileges over the repository, right? But it will automatically perform a workflow in the background, and maybe you could do something with that, right? A runner is the virtual machine that will actually run the workflow. So as I said, Ubuntu, Windows, and macOS is supported, and a job is a step in a workflow, right? So it could be a shell script or a custom action, right? So it's quite big what you can do with that. All kinds of scripting and programming languages are supported over there. So how can we abuse that? We basically already covered that. Let's say we, for instance, have the ability to open an issue, for instance, and we know that this will trigger a workflow in the background. Then depending on how the workflow is created, of course, and what it does and what it returns, you might be able to do something with that, right? In our lab, we will provide an example of that. So there it will be a GitHub repository that triggers a workflow when an issue is opened, right? So just opening an issue will trigger the workflow, right? So you don't really need any authentication to do that. You don't need any special privileges to open the issue. However, to restrict that, to prevent anyone on the internet just messing around with this, it is somewhat restricted. You will see that there will be some kind of authentication. Is just to ensure that only the students of this course will be using that, but otherwise it might even work without any authentication, right? Or with any regular account. So learning objective 10 is a pretty short one, but we will be seeing how we can gain initial access in Chain 3 using the refining wiki. So this is a web application that is part of all corporation, right, of their refining department. So let's go take a look at that and see what we can get from that website. Right. Let's open a new window. So yeah, obviously in a normal scenario you would have enumerated that somehow. So let's say we find that some internal documentation or sometimes even documentation exposed to the internet, right, on some hidden web page that you find during a test, right? So let's see what we can find in here. Obviously, if we go through that, it's really condensed down, so you don't spend too much time or waste too much time trying to find where the interesting stuff is. So take this with a grain of salt, but it can be possible that internal documentation that developers may not be aware of, that is exposed to the internet or is somehow accessible internally without any authentication, right, can contain some secrets, right? So here we have some code containing an example of how to create an issue on a public GitHub repository. So you can see over here, this is hosted on github.com, so on the internet. You won't be able to access this repository from anywhere on the internet without authentication, so that's why we are using an access token, right? So this is a GitHub pad. So this is a personal access token. This is basically an access token to access GitHub, to send API calls to GitHub, right? So this is what we will be using to interact with GitHub and create an issue, right? So here there's some code that will allow us to send a post request towards GitHub, to GitHub API, to create an issue on this repository, right? And the issue itself, we can create, define the title of the issue and the body as well. So let's actually look into that. Let's copy this code completely. Let's actually paste that in a notepad. Let's increase that a little bit for you guys. Okay, so this is the same code. We will modify it a little bit just to make it a little bit unique, right? So let's make that new issue 6 so that there aren't many issues with the same name. Let's make it that, and let's do the same for the body. Now we can just copy that code and paste that in PowerShell. Let's close some of the windows from the previous code chain. We won't need those anymore. Same for that one. All right. So let's paste that and actually send a request to create a new issue on GitHub, on this GitHub repository, right? So we see that the issue was successfully created, right, using our personal access token. So this is being executed with the privileges of a user, right? Which user? We can see that over here in the response. It is Alisa, right? So this is a user on GitHub. With this access token, we can create issues on GitHub in this private repository, right? So we see that an issue is created with ID 610, right? New issue demo is what we provided over there. So let's actually see if there are some comments on the issue, right? So we just created that, but a common scenario in case a workflow is automatically triggered in GitHub Actions is that the workflow might provide automatically some output, and it will provide that output by creating a comment on that, right? So let's actually see if there is a comment that is automatically created. So we will take that URL. Put it in a variable. And then you will send the request again. In this case, a GET request with the same header, so the same access token will be used. And we see that there is actually a comment on our issue that's automatically created. It says error creating issue, validation fails for one or more of the following. Create AWS VM user is required. Invalid characters fail to trigger build. So it seems that indeed, as we expected, as we already know because it is created that way, there is a workflow that is automatically triggering over here when we create that. But some error occurs. It seems like it needs the create AWS VM user in the title of the issue, right? So let's actually modify our code a little bit. Right, so let's maybe make that in the body, add that. Maybe if we add that in the body of our issue, it will trigger something else, right? So let's try that again. Create a new issue. So a new issue was created. issue 611. Right, so let's check the comments again. All right, check if a different comment is created, and we see that indeed a different comment was created. At this point, we don't really know what is it yet, but it seems to provide us some job ID. So this is the job ID that it provides us. So let's actually copy that because we might want to use that later on, right? So what is the job ID used for? We don't know yet, right? So we will see later on what this is used for. We will come back to that later, and this is actually all we had to do in learning objective 10. Right? So access the wiki, try to find some secrets. We found some secrets, and at least we found got access to GitHub Actions to get with that and trigger a workflow, right? So that is what we did in the objective 10. So very straightforward. We will do some other stuff with that later on, but just as an introduction, that was that, right? Authentication strength. So before we move on, let's look into that. And there was actually a question at the beginning that was asking about what does phishing-resistant multi-factor authentication actually mean? What does that entail? Well, we will tell you right now. Right. So we covered this very briefly in Code Chain 1. Right. So it will be some of the things we will already have said, but because there is a question, let's go into this a little bit further. Right? So in conditional access policies, you can now enforce an authentication strength, meaning that multi-factor authentication, you don't just can enforce multi-factor authentication, you can actually enforce a specific strength of multi-factor authentication, right? So some types of multi-factor authentication are considered stronger multi-factor authentication by Microsoft than others, right? And in your own organizations, you might define which type of multi-factor authentication options are stronger for your organization, right? Maybe you do disagree with Microsoft, and there are some other types of multi-factor authentication strengths you will want to use, right? So the authentication strengths basically will contain three default authentication strengths, right? So if you look at the conditional access policy, actually, it might be even better if we just explain this while we show it to you. For that, we will go back to bulk operation. And authentication strengths are the concept that's defined under conditional access, right? So you will see that there is something called authentication strengths. If I click on the right one. And basically what the slides are telling us over here is that there are three default authentication strengths, right? And you can see them over here as well. And so these are the default authentication strengths that Microsoft has configured. We have multi-factor authentication, the weakest one or the most broad one, because if we click on that one, we will see that it will contain all multi-factor authentication options, right? So Windows Hello for Business plus keys, certificate-based authentication with also just password plus multi-factor authentication app from Microsoft, Microsoft Authenticator app, password plus SMS. So every type of multi-factor authentication will satisfy the normal multi-factor authentication strength. Above that, you have some more specific ones. The second one is passwordless multi-factor authentication. So this one contains all the authentication methods without a password, right? So Windows Hello for Business will automatically sign you in on your device if you the device is configured to do that, right? Pass keys, that FIDO2, for instance. You have certificate-based authentication, and we have the Microsoft Authenticator phone sign-in without providing a password. That is also a possibility, right? So these are our passwordless multi-factor authentication methods. And then you have one stricter one, and it's basically the same as the second one without the Microsoft Authenticator app. Right, so here it only has Hello for Business, passkeys, and certificate-based authentication. Right, so let's say, for instance, you want to be very, very strict and want to create a conditional access policy where you require multi-factor authentication, but you don't want to just satisfy any multi-factor authentication. You only want this resource to be accessed if a specific type of multi-factor authentication is used that you consider to be stronger. For instance, if you do two certificate-based authentication and with this Hello for Business, right? Because these are what Microsoft calls phishing resistant, meaning that you cannot just create a malicious web page like totally legit Microsoft.com and host a fake login page on there and let the user sign into that with Windows Hello for Business, passkeys, or certificate-based authentication. It just won't work. Why? Because Windows Hello will not authenticate to anything that is not a legitimate Microsoft website. Same for passkeys, right? It will just not do that because it will look at the domain and it will not have anything stored on your passkey for the malicious domain. Same for certificate-based authentication, right? Because it will be based on the domain that's specified in the certificate. Right? Does that mean that all of these are equally strong? Well, maybe not. We will look into that a little bit later, but at least from the perspective of creating a malicious web page, you will not be able to phish that. You can still social engineer a user into taking some actions, right, that would give you access, or you can still compromise their complete device and then you will also gain access, right? But you will not be able to phish that, right? Exactly, as John comments, with Windows Hello, the authentication is done at the device level using a PRT. So if the device is compromised, the account is also compromised. Yeah, of course. So it's phishing resistant, meaning that you can't really just create a malicious website that would capture the authentication material and relay that towards Microsoft. That's not possible. Even with something like EvoGenX, not really possible. Right? But there are still ways to abuse that, right? If you compromise the device of the user, you will still be able to use it. Right? Regardless, this is still a good control if you want to restrict access even further. Right? So where do you actually configure that? Under the ground control, you can just require multi-factor authentication, then any multi-factor authentication will work, or you can require a specific type of authentication, multi-factor authentication using the authentication strength. And so if you just select the first one, it will be the same as checking this box. But if you select passwordless multi-factor authentication, it will only allow you access if you use one of these four passwordless methods, or phishing resistant only allow it with one of the three phishing resistant methods, right? And you can configure your own multi-factor or authentication strength as well, right? You can select, if you see over here, yes, and then you can select your own combination of authentication strengths to create your own profile, right? Okay, let's go back to the slides. So we covered all of that. Custom authentication strengths can be created as well. One of the phishing-resistant multi-factor authentication methods is certificate-based authentication, right? So as we saw, certificate-based authentication is also in there, right? Can you phish users using certificate-based authentication? Well, you can't, as we said, create a website that would steal the authentication or intercept the authentication when certificate-based authentication is used. It's not possible, right? because you don't have access to the certificate itself with the private key in there, right? But you can still social engineer a user into sharing their certificate with you, right? Or the user is just careless and puts it somewhere on their OneDrive or on SharePoint where everyone can see it, right? So a lot of places where you can actually find certificates, right? If you look at the certificate-based authentication, phishing resistant strength, so you will see there are some advanced options, right? Let me show you that. If I select certificate-based authentication and go into advanced options, you will see that there are some other things we can restrict, right? So you have certificate issuers from the certificate authors in your tenant, right? So if you select that, then only certificates from this certificate that is already configured in our tenant will be allowed, right? However, you can also create a certificate or also do it by certificate issuer, right? By the subject key identifier. And in this case, you can use, indeed, as John says, you can use a self-signed certificate and even a certificate that's not even in your tenant, as you can see over here. The weakest configuration over here would be if you select other certificate issuer by subject key identifier. Because what is the subject key identifier? Is basically just an attribute in your certificate that will automatically be placed in your other certificates that are issued by that certificate, right? So if you have a CA certificate, its subject key identifier will automatically be placed in every certificate that was issued by that CA in another property called an authority key identifier, the A kit, right? And this is the S kit, right? So this basically allows us to somehow see that or to assume that certificates with this subject key identifier are probably, or with this authority key identifier, are probably issued by the same CA certificate. However, there is no cryptographic link between the AKIT and the subject key identifier, right? So we can, as an attacker, just create our own CA certificate, right? Self-signed, and put any subject key identifier that's in there, right? So if we know the subject key identifier that's configured over here, we could create our own self-signed certificates, and that would also work, right? So it's not very safe if that is used, right? Just to provide you one example. All right. Yeah, obviously, if we are able to steal the certificate of a user, then we can also use that for authentication and even multi-factor authentication, right? So where can we find certificates? If you compromise the machine of the user where the certificate is stored, right, it will be in the user certificate store. You will be able to extract that if you have administrative privileges, right? Then you should always be able to also extract the private key, right? If the certificate allows that, and if it doesn't allow that, you can use something like Mimikatz to still get it out of there, right? But even then, if you don't want to get it out of the machine, there are so many locations where certificates are stored, right? Like SMB shares on-prem, key vaults, you can find them if you have access to that, storage accounts, automation accounts, app services, just to name a few of the Azure resources where you can find them, right? Or just on OneDrive or on SharePoint, somewhere in some documentation folder from IT, right? Or if you have compromised on-prem already, and there is some ADCS server, it is also possible to in Entra ID trust the root certificate of your ADCS server, and then you might be able to issue certificates from the ADCS server on-prem and use that to access Entra ID, right? So a lot of places where you can get these certificates. Do we cover how to extract private keys from the certificates used for authentication? Well, usually, in a lot of cases, it will already be in the PFX file, right? So if you find a certificate file, there are certain formats. There are formats where only the certificate itself is in there and not the private key. There are formats where only the private key is stored separate, right? And then you have a .cert file commonly and a .key file, right? And it's stored separately. But in a PFX format, they can be stored both together, right? So if you find a file like that, then you will already have the private key, right? And we will see that, right? All right. So before we continue with the learning objective, something else that we want to cover is using automation accounts. So what are automation accounts? As we previously covered already, just like logic apps, they allow you to execute actions, right? Automated actions, right? But automation accounts are more focused on creating Azure resources and managing Azure resources, right? Using runbooks. So this is also a concept that we already saw in the basic course, right? However, we will look at something else over here. In the basic course, we mainly looked at the runners accounts. So these are being retired already. So here we are going to look at some other things you can do. But basically, if you have some kind of read access over the automation accounts, right, you might also be able to find sensitive information in the automation accounts, right? So all of these permissions that are listed over here are able to read some information from the automation accounts, right? Right. So the normal read one might have a little bit less permissions, but if you can read the jobs and the run books, then you might be able to find some information in there, right? Okay, so other permissions or role assignments that you can have on a automation account, for instance, automation contributor, automation operator, and automation job operator, all of these will also be able to read job output, right? And that is not even covering the normal RBAC roles like owner, contributor, and things like that. Yeah, you can indeed use it for that as well. Okay, so let's go to the portal once again. One thing that I wanted to show you, so you have here the certificate issuers, where it is configured, right? I said you can configure these certificates in your tenant. Let me show you that really quickly. If we go to Enter ID, security, and then we go to certificate authorities, you'll see this is stored over here, right? Okay, then the automation accounts. Let's quickly look at how these look like, right? So we have one automation account in the all corporation tenant. Managed multi-cloud is what it is called. And we will see if we go to runbooks, or let's go to connections first. So the connections are the credentials. Yes, there are some credentials configured over here. So we cannot get the credentials out of there, right? Not possible to get them out of there from here, right? However, these credentials are defined on the automation account, meaning that all runbooks that are defined under this automation account will be able to use these credentials, right? So if you would be able to, if you have permissions to write in the runbook, you will be able to get these credentials out of there, right? Because they are used in the runbook, right? Or they are exposed to the runbook, right? Here we can see, if we go to the runbook itself and see the actual code that is defined over there, you will see that these AWS credentials are actually used. So these are retrieved in a secure manner, so there are no clear text credentials visible in here. So it only reads access to the runbook. You will not be able to see any credentials. However, see that these credentials are used later on to manage some AWS server, right? And we'll see that it will actually create a username and password on this AWS instance, right? All right. So let's look into the learning objective. We will actually go back to this web page because we only went through this very briefly, right? So we saw that there were some GitHub access token in here allowing us to create an issue on GitHub, right? This is what we found already. But if we were a little bit more careful and went through all of it, we would see that there are even more sensitive information on there. Right? So we also have clear text credentials for Christina W. Burris, a user from our corporation, right? And what else do we find? If we scroll down a little bit, we also see that there is a certificate that can be downloaded from here, right? So let's download the certificate. Actually, we already have it, so no need to import it again. And we also have these credentials over here. So let's actually use these credentials, right? We have some credentials. It's already in the right format to connect to Azure, so very convenient. We can just copy paste that and try to see if we can get access to this account. And as you guessed it, multi-factor authentication is required, right? So multi-factor authentication is required. Let's actually look at that. Conditional access policies. We could also use a technique from learning objective 1 where we enumerated the conditional access policies already using the policy.read.all, or we could use the AD internals 1.61 version as well to enumerate conditional access policies. Right, so I'll maybe leave that as an extra thing for you to do, but what we will do is we will just look into the conditional access policies and view it from the portal using the privileges that we have. Indeed, we will see that later, John. Okay, first, the phishing-resistant multi-factor authentication. We see that there is a conditional access policy called phishing-resistant multi-factor authentication, and the user Christina is assigned to that. Right? So only the user Christina, the one that we just compromised, is assigned to that. And it is the user is granted access, however, only when they use phishing-resistant multi-factor authentication, right? So we will be able to gain access to her account unless we have some way to satisfy the phishing-resistant multi-factor authentication, right? However, the certificate that we found over here, this one, if we go to that one, not that one, this folder, we'll see this also has the name of the Christina user, right? It's a PFX file with the name of the Christina user, so probably a certificate for this user, right? So let's try to import that in our current in our user store, right? On our certificate store, right? Do that, and we will see that this will prompt for a password. As John already mentioned, it will need a password to access the private key in there, right? So do we have the password of the certificate? No, but users are usually lazy, right? And we know the password of Christina itself, and usually there's a high chance that they reuse passwords, right? So we can assume that in this case, the user will be reusing the password for their Entra ID account also for the certificate, right? Because then they only need to remember one password, right? So let's try to see if that works, and it seems to do. Automatically select the certificate store, yes, that's fine. And if we click finish, the certificate would be imported in our certificate store, right? Let's not do that because I already did that, just to show you guys where you can find that. If you go to manage user certificates, personal certificates, here you will be able to see all the certificates we imported, and we see that certificate is in there, right? You'll be able to see all the details, right? And we have the private key also imported over there, so we will be able to use that. So phishing resistant multi-factor authentication is required. So only if you have the certificates, you would be able to authenticate in this specific case, right? Let's actually try to authenticate as this user. Portal.azure.com. Are we already signed in over here? No, we are not. So what you will see that is if certificate-based authentication is enabled for a user, we provide their username, and we have a certificate already in our certificate store. You will see that it will prompt us automatically to use that certificate instead, right? So we don't provide any password even, we just select that certificate, and we will be signed in. Because this will satisfy the phishing-resistant MFA, right? Question is, in PowerShell, can we use a certificate to authenticate? So connect, for instance, you mean probably to connect to AZ account, right? Use this command connect AZ account. You will actually not be able to do that. You can provide a certificate, but only if you use a service principal, right? So it will only allow you to authenticate with service principals, sadly enough, right? However, if you really want to, you can, using the technique that we performed previously, right? I showed you that last time. This, if you go to all resources, now there will be access tokens being used. So if we go over here, you'll see here's an access token for the ARM API as user Christina, and we can use that to authenticate to the Azure portal, right? However, none of the Azure module, of the PowerShell modules will allow you to authenticate with the user certificate directly, as far as I know. Right. Another, while we have this open, another location where you can find these certificates, right? So you can go through the network requests and copy them from there. However, where are these actually stored in your browser, right? They must be stored somewhere, otherwise it won't be able to put that in your request, right? So if you go to application and go to your session storage, portal.azure.com, you will be able to see that there are quite a lot of entries in here. And if you don't think that I can make this bigger, I can. Let's make it a little bit bigger. You'll see there are access tokens in there and even refresh tokens, right? So you can take refresh tokens as well. So the access tokens, you will be able to see. This one is for management.windows.net, and you have another one over here, right? So this one will allow you to access the ARM API, right? You can take that certificate, that access token from here as well. Okay, as a sidetrack. At this point in time, we also already went to all the resources. So we see there is a runbook over here and an automation account. So this runbook is part of the automation account, and actually this is the same automation account that we already saw previously when I used the admin credentials, right? But here we will be able to see that as well. So if we go to the runbook itself, we can go to the jobs. We'll see that it has executed a couple of times already, right? And remember from previously, we had a job ID, right? Let's actually see if the job ID that we had previously will be something that we can find over here. Right, where did we get that job ID? Let me see if I can still find it for you. Here it is. Right. Remember when we created an issue on GitHub, the job ID was returned over here. So let's actually find the job ID over here. Maybe it is related to that, right? And it seems to be, right? So when we created that issue, the GitHub action that executes the workflow seems to have automatically executed this runbook, right? And then returned the ID of that job that got executed inside the comments of the issue, right? And if we look at the output, we can see that there is some information that will be useful for us, right? So the automation account, as we saw previously, the runbook creates a new user on a AWS machine, right? So on an EC2 instance with this public IP. So we can copy all of that information and use that later on, right? We could have also just exported the access token and enumerated this from PowerShell as well. It's all defined in the lab manual, so if you want to do it that way, you can follow that as well. But it will just give us the same information. So it is possible to enumerate all of that using the PowerShell modules. However, you would need to get an access token from the tenant because you can't use a certificate directly here, as we said. But this is all for this specific learning objective, right? So where are we right now? Let's show you. So we started, if we zoom in a little bit, we started by finding the wiki application, which contained quite a lot of credentials, right? It contained a GitHub access token, a personal access token, the GitHub pet, which allowed us to create an issue, and that triggered a webhook in GitHub with GitHub Actions that actually triggered a automation account or a runbook from that automation account in Azure, right? That we later found out we got that job ID. Do we actually have needed that? Well, in a normal scenario, maybe there might not have been any job histories yet, right? So you might have needed to trigger this first, right? To actually be able to see the output of that, right? Here, you would probably just have been able to use the output from another student that already created an issue, right? Or if we assume this is a legitimate scenario, the real developers might have created an issue already, which would have triggered this runbook as well, and we could have used that output as well, right? So that is where we ended first. But on the wiki, we also found a certificate for user Christina, which we were able to decrypt the private key from using the password of the user, right? With that certificate, we can not really bypass multi-factor authentication, but we can satisfy the phishing-resistant multi-factor authentication that is required for the Christina user to access any resource, allowing us to access Azure, where we found that we were able to read job output from the managed multi-cloud, or from a runbook from the managed multi-cloud automation account, right? Which gave us credentials for a user on an AWS instance that we will see later on, right? So let's actually continue from here. Okay, token extraction. So Microsoft is pushing a lot of users to use a license for their application, for their Office 365 applications, right? So you can no longer, it's not really supported anymore to use or to just buy a lifetime version of, for instance, Word 2008 or whatever, right? So it's pushing all of its users to a subscription model where you pay every month a little bit for every user using that application. And if they have an Office license, then they will be able to use Word and PowerPoint and Excel and whatever that your normal business users need, right? Just so that they can make more money out of that, right? Because you pay a monthly subscription for that or a monthly license for that, right? And because of that, it also integrates a lot better with other Office 365 applications like OneDrive, like SharePoint, for instance, right? You can automatically see when you open Word, for instance, you can automatically already browse some files that are stored on your OneDrive, right? So how does that work? Well, it will need an access token. Your Word process will need an access token to be able to list all of the files that you host on OneDrive, right? And get some other information, right? So that means that this is a useful location where we could, for instance, as an attacker, if you compromise a device of a user, we could try to get some access tokens from, right? There was a blog post, I think somewhere last year or 2 years ago, where someone found that access tokens are stored in clear text somewhere in log files from Microsoft Teams, for instance, right? But there are a lot of other locations where we can get these access tokens from, right? So multiple ways of getting these access tokens out of there, right? So for instance, if you compromise a device and there is a user on there who has a Office 365 license and is using Word and Outlook and whatever they are using on there, right? You can, for instance, intercept all the network traffic that these processes generate and get the access token out of there. Of course, that will be encrypted, HTTPS encrypted, so you would already need to import a certificate into the trust store of the device, which you can do if you have admin privilege on the device. And then you can intercept all the HTTPS traffic and you will be able to get the access tokens in there. So something that is possible, right? Tokens of interest would be probably for the Microsoft Graph API mostly, right? Because the Graph API is the single gateway that allows us to access quite a lot of stuff, right? So a lot of stuff from Enter ID, but also from Office 365 services like OneDrive, Outlook, SharePoint, right? With just a single access token, you can do so much if you have a Graph access token, right? However, as is noted at the bottom over here, you will always need to be a little bit careful of when you do things like traffic interception, right? If you have a foothold on the device, right, and if you mess with the traffic, you might lose your foothold, right? So if you are changing certificates and intercepting traffic and things like that, the user might start seeing that, right? If you're not careful enough in what order you do your steps, right? If you, for instance, think you have imported your certificate, allowing you to perform and in the middle with HTTPS traffic, but you haven't done it correctly, right? It's in the wrong certificate store or in the wrong container, right? Then that will mess up all the HTTPS traffic for the user as well, right? So be careful when doing things like that. So in the lab, we will not be doing this. However, there are a lot of other techniques you can use to get the same access tokens, right? We don't need to do that. There are easier ways. We can, for instance, sorry about that. We can, for instance, just dump the memory of an Office 365 application, right? So because the Word application, for example, in this case, will need to perform some API requests authenticated as a user. So it will have stored access tokens in its process memory, right? So Office 365 processes and browsers, for instance, have become the new ELSAs, right? A lot of EDRs are looking quite a lot at protecting the ELSAs process because there are hashes in there, NTLM hashes, reverse keys, tickets, things like that. Right? If you all EDRs are protecting that, so if you just try to open a handle of the Azure process and you do that from a suspicious service, it will already be suspicious, right? Definitely if you try to read the process memory, right? But they will look less often to your browsers and your other applications like your Word and things like that. If you read the memory of a Word process, less suspicious than reading the process memory of Elsa's, right? So we can dump the word process and extract the tokens on another device, for instance, like Mimikatz does for the Elsa's process. Right. And the third location where you can get these same access tokens is by decrypting them from the cache. So by default, these Office applications will cache the access tokens in a file, right? It will be in your local app data, so it will be scoped to the app data of a specific user, right? And if you go to Microsoft Token Broker Cache, in this directory, it will contain a lot of .tbres files, right? So these are encrypted, but with the DP API, right? Awesome research by this researcher, Alexis, I think, of Adam Chester, right? Who found that and created a tool to decrypt these tokens, right? So these are encrypted with DP API, meaning that the user with its own privileges will be able to decrypt that. So you don't even need admin privileges to do that. Same for dumping the word process memory, right? Because it will be running in the context of the user, right? But here, in the context of the user, you would be able to decrypt these cache files and find some access tokens in there, right? Clear text. So 3 methods, as we said. We can intercept the traffic. If we really want to, we can also do memory scraping. We can dump the process memory, or we can just decrypt the cached tokens. All of ways you can do that. We will look at the bottom 2 ones. We will look at memory scraping and cache tokens. Which brings us to learning objective 12. Okay, so using the credentials that we extracted earlier, we can now try to access the AWS virtual machine, right? Using PowerShell remoting, right? So let's actually go back. And over here, we have an IP address of a virtual machine, a public IP address, right? Let's check first if PS remoting is enabled, right? Otherwise, we wouldn't be able to connect to that with PS remoting, but we see using this command, we see that it is actually enabled because we get some output. Otherwise, we would not get that, right? So now we can use these credentials on this account to connect to that virtual machine. Right? So let's do that really quickly. Over here, let's create a new credentials object and create a new PS session. This is using PowerShell remoting, right, towards this device, right, and let's connect to that session. Right, so now we have a shell on that host. Let's confirm that by checking the host name. So we see over here, it's an EC2 Amazon and somewhat host name. So everything pointing in the direction that this is probably a virtual machine in Azure. If we check who we are this local user that was created on this device using by the runbook. Right? How can we confirm for 100% sure that this is an EC2 instance? Well, we can interact with the instance metadata API or the instant metadata service, right? So this IP address is a non-routable IP address that will be accessible on every AWS virtual machine. So this is basically an API you can interact with from the virtual machine itself to request some information about the device and share some other details with the devices you will see later, but just a basic request to check the host name as defined in Amazon itself. And since we get a response, this means that this is actually very, very likely a virtual machine, right? So if we would exit that and would try to execute this locally, we get an error message forbidden, right? Enter the session again. So it's a non-routable IP address, right? It will not go anywhere. It will go to Amazon itself. You can't really access that remotely. Only from within the VM you can query that. Right. Okay, what can we do? Let's list the processes on this device, right? Really quickly, because you will probably already know where this is going to, right? Because we will see that there will be a process called invert, right? As which user is it running? It is running as a local administrator, right? So we might have administrative privileges already here, right? But accessing this process would probably be better than if we get access to the credentials of the administrator user itself, right? So just as an example, something that you might find actually is still being used today is sensitive data being stored in the user data, right? So this instance metadata service, you can configure some user data in there. So you can configure that in Amazon itself, and it's basically a way to store some data like an environment variable that the virtual machine can access, can request when it wants to, and it's user defined. It can be anything stored in there, right? And if you can store data somewhere, you bet that administrators will put credentials in there, right? So we will see over here, there are some scripts over there, probably there is some service over on this device that will query this API and execute some PowerShell code that's stored in there, right? But we also see if any error encounters, try to log in with the administrator credentials, right? So we get access to the administrator credentials. Awesome. So we know that Word is running over here. We can assume that there will also be some credentials cached for this user in the token cache, right? So let's actually look at that, because to be able to decrypt the files where the tokens are stored in, we need to first get access, or we need to run in the context of the administrator account, right? Because they will be encrypted with DP API in the context of the administrator user, right? So that is why we need these credentials. But to extract these credentials, we will use some tools that make it a little bit easier to do that for us. And we will first want to copy them over from our attacker machine, right? So let's copy some tools over. We will get an error message over here saying that, well, this already exists. This one didn't, so it copied it correctly. Right? And what are we copying over? This directory containing the tool that we will use to decrypt the tokens later on, right? As well as invoke run as CS. This will allow us to run the tool that we will be using with the privileges of this administrator user, right? We can't use the normal run as, because that would spawn a new process, right? And the new process we would not get access to. With invoke run as, that will execute a command prompt within our current session, right? Within our current PowerShell session. So that is what we are going to do. Let's connect to the VM again. Let's switch to the directory. Okay. So what are we doing over here? We're importing this invoke run as. So you can think of it as just the regular run as, but it allows us to retrieve the content of the process in our current session without spawning a new session, right? So we're using the credential of the administrator user with the password of the administrator user, and we will be executing the tpress.exe. This is a tool that will decrypt the tokens for us. Let's do that. And you see that the tool automatically found all of these tokens files, these cache token files. Where did he find that? We go back. It found it in this directory in the local app data of the administrator user in Microsoft Token Broker Cache. Right? All these files. These were encrypted, but it decrypted it with the privileges of the administrator, right? And it stored them in decrypted files. So since Invoker NS will change the directory to C Windows System 32, this is where it will be stored, right? So if we show that, if we list the contents of the System 32 directory and list all the files ending with the extension decrypted, we will see that these are in there, right? So, and the ones that we did over here, you will see that these are in there as well, right? There are some other ones, older ones from other student users doing the same technique, right? That is why we are sorting them by time, right? Okay, so you will see that in there will be actually access token stored. So you can look at the length. Let's maybe take a longer one, like that one. Let's take this file. Since it is decrypted, we can now see everything in there in clear text. So let's do that. And you will see there is quite a lot of data in there, right? So we will get some access tokens. In this case, for Outlook, it seems, right? So this is basically the scope. It stores that as well with that. And after that, we see some tokens, right? It could be an ID token or an access token. But usually the longer ones are access tokens. But we don't really know for what specific resource it is from, right? So let's take this one, for example. Let's throw that in jwt.io. And see, so this one is for Outlook actually. We want to find one for the Microsoft Graph API, right? So we could go over these one by one. Let's speed it up a little bit. Let's use this. So we will iterate over all the files, sort them, and then get the content of each file, and only list the lines containing graph.microsoft.com and the starting indicator of an access token, right? So access tokens will always start with this. Why? Because it's just base64 encoding, right? And the access token will always start with this. It's JSON data, right? So it will always start like that. Let's do that. Okay, so now it listed all the access tokens from all of the files. Let's scroll up a little bit because they were sorted by time. Okay, let's scroll down a little bit, see until we match a line containing graph.microsoft.com. So probably in the same file, there will be an access token for that. This one is too short, seems to be an ID token. This one will probably be an access token for graph.microsoft.com / let's validate that. And we see graph.microsoft.com as our audience over here, right? It's for Microsoft Office. Is it still valid? Let's check. So it was issued at October 19th, so today at 3 o'clock 51, this local time of this VM, and it expires tomorrow at 4 o'clock, so 24 hours later. Right, so this is unusual because normally access tokens are only valid for 1 hour. Anyone knows why this access token is valid for 24 hours? We covered it briefly last time. No one knows. If I scroll down, you also see this. Anyone knows what this means? You have a claim XMC, CC, CP1. So this is an indication that continuous access evaluation is in use, right? Remember from the basic class, continuous access evaluation will allow Microsoft to revoke access tokens even if they are not expired yet, right? So therefore, the access tokens will be valid for a little bit longer, 24 hours like we see over here, right? Because Microsoft knows that if the user is compromised or if the user resets their password, they can instantly revoke that access token and it will not be usable anymore, right? That's what continuous access evaluation is. Also, conditional access evaluation allows you to, if you have a conditional access policy, to only allow the user to authenticate from the company organization's public IP address, right? Let's say the user is on site at their organization, at the office, requests an access token, right? It is cached, and the user quickly walks outside and connects to the Wi-Fi of a local Starbucks or coffee shop nearby, right? Then it will use another public IP address. Without continuous access evaluation, that access token could still be used because it will not check if the user suddenly connects from another IP address, right? However, with continuous access evaluation, Microsoft will see that the user changed public IP addresses and the new public IP address will not be allowed anymore by the conditional access policies, so it will block access, right? So that are some things that continuous access evaluation allow you to do. And this is a good indicator that continuous access evaluation is in play, this claim, as well as the lifetime of the access token. All right, so enough about continuous access evaluation. So let's actually use the access token, right? We can do various stuff with that, right? We can import that into PowerShell, or we can just import it into GraphSpy as well, right? If we go to GraphSpy, which is still running on our machine, we can import the access token over there. You will see that GraphSpy will also be able to decode it, so you can use that instead of gwt.io as well. We can activate that. And now we can do anything with the access token that you want, right? So something that I have not showed you, if you have an access token for the Graph API, you will be able to access files on OneDrive, right? So if you click on the OneDrive module, it will list all the files in OneDrive, right? So there is a file over here, access plant info.ps1, some documents over there. We can browse through the documents. Are there any attachments? No. So this makes it a little bit easier, right? So in the background, GraphSpy will just be sending API requests and will display the information a little bit easier, right? We can even download the files directly from here. If you click the download button, there we go, we have the file over there, right? For that, we would need the scope files.read all, or files.read all, right? So this is what you can do with GraphSpy, right? However, in the lab manual, it will tell you to use PowerShell. So you can use PowerShell as well. Let's do that really quickly. So let's take the access token. Useful from GraphSpy as well. You can always have an overview of your access token and copy them from that. So let's import that access token. And we can also send these API calls manually, right? You will quickly see why a tool like GraphSpy can be a little bit easier to do that, right? So here we can just send an API call to list all the files in the OneDrive of the user with the graph access token, right? Just a GET request. And if we do that, we get quite a lot structured output, right? So it will just be some JSON data, and there are a couple of files in there. We have one folder, an attachments folder. If we would want to see the contents of this one, we would need to send another API request and see what's in there. What else do we have? The access plant info.ps1, another document, and things like that. Not very structured. We could make it a little bit better. If we would filter that a little bit down in the table, but let's first now just get the access plant info.ps1 if you want to download URL of that. Let's do that over here. And we, with that download URL of this file, we would be able to download the file as well. So let's do that really quickly. If we just take that URL and visit that, we'll also get that file. Right? So a couple of ways how you could do that. We have a question. In your example, where the user authenticates from Starbucks changing their IP and continuous access evaluation is in effect, would continuous access evaluation revoke the token, or if the user goes back to their company's IP, would that existing token work again? The existing token would work again. So maybe revoking the token is actually not the right term for that. The token would still work, right? It will just not allow you to request the information. Another follow-up question. This would also rely on enforcing the company's IP and network locations in the conditional access policies, right? Yes. So if you don't have a conditional access policy to restrict access to a resource from a specific source IP address, then continuous access evaluation would not do anything, right? But if you do that, then you can try that in the lab, right? So if you take the access token that we stole over here from the user and try to authenticate outside of the lab, you will see that it will not work from the public IP address from outside of the lab, right? Because continuous access evaluation will not allow you to do that because there is a conditional access policy that only allows you to connect from the student VMs and from inside of the lab network, right? But for all other access tokens that we saw previously, that were only valid for 1 hour, without continuous access evaluation, there you would be able to use them. Right? Okay, so we will continue probably for another 30 minutes right now to finish this off. But obviously this will be recorded, so if you got to go right now, that is fine as well. Yeah, indeed, it's interesting that it does extend the lifetime of your access token because, the Microsoft assumes that you will configure conditional access policies that restrict the access from a source IP address, right? So then the impact is reduced for the access tokens being valid for longer, right? Okay. So if we open that file that we just downloaded over here, so open that, you would see that it contains some credentials. Right? It contains, once again, clear text credentials of an admin user on a specific other IP address. Right? So this is a local user account, an admin user, and here it is an Enter ID account, so a file admin account. Right? Also the password of that, we also get that. Right? Okay, that's great. Let's actually something else that we can do is list the contents of Outlook, of course. Right, so you'll see in the lab manual that's also configured or described over there. With the mggraph API or PowerShell module, you can actually, using the same access token, list contents from emails. So let's do that as well. So once again, not the best output you can imagine, right? So all the details of the emails. If you want to see a little bit of a better summary, we can do that as well, right? So we have a couple of emails here with subject Christina Burris wants to access plant info, accessing the plant information file share, and the test email as well. And this one seems to contain also some credentials, right? If you would want to see the complete body of this email, We can do that as well if we just take that ID over here, right, and request only that specific email with that ID, and then get the body and the content out of there. You can see the complete content of that email in the mailbox of the Casey user, and we see that the same information is also stored in an email, right? Also very common for users to receive credentials over an email, and then if that was not bad enough, they just put it on their OneDrive, right? So that anyone can see it later on as well if they get compromised. So the same information over here in the email as in this PowerShell file that we found on the OneDrive of the user. Okay, let's also show you very quickly how we can extract the credentials of the access tokens from a Word process. Actually, we want to exit this over here. We want to copy some other tools, right? To the attacker machine, we will copy PropDump and the strings.exe program towards the AWS instance, right? So we already got the access tokens, but just to show you the other technique as well, if we go to this folder, right, we have strings.exe PropDump, and we also have some terms from previously already. Let's create a new term. So you can see that. Get process name in Word, right? And then we get the ID of the Word process that's currently running, right? We found that out previously that this was running as administrator user. So what we can do is use PropDump, since we have admin privileges on this device, to dump this process. Right, 7080. Let's dump that process memory, and then we get a dump file, right? You can now extract this to another attacker machine, right? If you don't want to trigger some more noise on this device, you can do that, right? But in this case, we will just use the strings program over here to find access tokens in the dump file. So we want to use this new one, and we will find, it will first get all these strings out of there, out of the process, and then we will only show the ones containing a potential access token. Let's do that. And this will actually take quite a while. But it will actually eventually give us the access tokens, right? In the meanwhile, let's actually show you another technique as well, very, very quickly. In another VM. So we will leave this running in the background. So in another window, let's connect to the EC2 instance again. And once we have that, let's use Azure Token Finder. So this will do a little bit the same thing, but it will be a little bit faster, right? And it will provide us a lot cleaner output. So we will copy the Azure Token Finder tool towards the EC2 instance, right? Enter that again. And now we will run Azure Token Finder on the WinWord process. And let's run that. And we will see it's a little bit more efficient. In the background, we also see the access tokens from the strings being returned, right? So as you can see, a lot of access tokens are stored in the Word process, right? But here you would need to check all of them, see if they are still valid, if they are expired, for what audience they are, right? Are they from Access Graph or something else, right? Azure Token Finder, if you go back to here, is a little bit more useful to use. However, chances are high that this will be detected by some EDR, right? It will show you a clean output, right? So it found an access token for Outlook with these scopes, right? And some other ones, another one for Outlook, probably one for Microsoft Graph in here as well, if we search the left, right? But actually, what we could do also is use a token for Outlook to access the emails, right? You can use that doing with Graspy, right? So if we put the token in there and click on open, sometimes it works, sometimes it doesn't. Might have been expired token. There we go. We get access to the mailbox of the user, right? And this answers a question that was asked by Andrew. Can we inject the tokens in a browser as we do with cookies? And the answer to that is no, except for Outlook. So the only process where this will work is Outlook. If you have an access token, not a graph token, if you have a token for Outlook, outlookoffice365.com. If you import it in Graspy, enable that, go to Outlook, and this will allow you to open a mailbox as user. How does it work? It sends a specific request towards Outlook using the access token, and Outlook will return cookies for that will be used, be able to that you can use to access Outlook, and it will work just like if you are accessing Outlook manually, right? And here you can see the constant email. You can send a new email. You can do whatever you want, right? So far, we have only found this technique to be working for Outlook. Right? We haven't found this to be working for anything else. But I have integrated that in Graspy as well, so you can use that a little bit easier, right? Okay. And that actually ends learning objective 12. So user credentials extracted earlier to access an AWS VM. We extracted access tokens for the Word application, and we use those access tokens to extract other credentials from OneDrive and the mailbox of the user Casey. Right, so where does that bring us? We are currently over here, so we got the credentials to access AWS VM. We found credentials for the built-in administrator, right, which was running a word process. And there are two ways to extract tokens from that. We can extract it from the cache tokens. We can extract it with memory scraping. A third one would be to intercept the network traffic, would also have worked. And using any of these techniques, we can get the user access tokens to access OneDrive and Outlook as well. Right? As we saw, both of them contain the same credentials for a user named fileadmin. Right? Okay, so we are. There's only one learning objective left, is a shorter one in KC3, and I really would like to cover this one as well, if you guys don't mind. We probably need another 20 minutes to go over that. But obviously the session will also be recorded. Any questions about things that we already covered so far? Okay, in that case, let's move on to the last learning objective for today. If you haven't noticed, Microsoft has enabled Kerberos authentication for an intra, right? So they saw that a lot of their clients were still running applications that are relying on Kerberos authentication, right? So since a lot of clients request that, they have moved Kerberos to the cloud, and now you can use Kerberos in certain cases to authenticate to some Azure resources, as we will see later on, right? So that is the reason why they did that. Specific use case that they mentioned was, let's say you have an Azure virtual desktop, right? And on that virtual desktop, you are using roaming profiles, right? So the roaming profiles will contain some settings like the app data of the user will automatically roam with the user, so that doesn't matter on which device they log in, their same application data will be present, right? Or their backgrounds will automatically change, things like that, right? However, usually on-prem that is stored on some file share, right? However, Microsoft also wants to support this to store that on a storage account, so on a file service in Azure as well, right? But the virtual desktops will need some way to authenticate to that natively, right? Because or they could completely modify the normal flow of how the roaming profiles are retrieved, right? They're just using SMB, right? But the SMB will not be able to use access tokens to access the information from the file share, right? So how do you make that happen? Either you they change how SMB works and allow the device to authenticate with access tokens over to an SMB share, which would be a little bit weird, right? So they came up with, we just add Kerberos authentication to file shares in Azure, and then it will work automatically, right? If the user has, or if the device has tickets for that, right? And then it will just try to access the SMB share and use that ticket that is already built-in functionality. SMB can access or your SMB client can use Kerberos authentication to access an SMB share, right? So nothing needs to be changed there. So this is just an example. Other applications might also support Kerberos authentication to access a file share, for instance, right? So this is what Microsoft Entra Kerberos will allow you to do, right? So this essentially means that Entra Kerberos allows hybrid users to access Azure file shares over the internet using their on-prem credentials. So that's what it says over there, but very important, hybrid users. Only hybrid users are currently supported, right? So no cloud-only users. Hybrid users will be able to use that. However, Microsoft has said that after some time they will also support this for cloud-only users, but it is not there currently yet, right? For now, only hybrid users will be able to use that, right? You will see that Azure file shares will only allow one type of authentication at a time, so I will show you that later on. And another requirement is that client machines must be either Entra joined, so fully joined in Entra, or hybrid joined, meaning that they also have are joined onto an on-prem domain. Right? You will see an example in the lab of an Entra joined device. Right? So let me actually quickly show you that. Actually, I'm not going to show you that because we can enumerate that in a bit during the learning objective, right? Without needing our admin privileges. Right. So if you do that, there will automatically be an app registration being created, automatically generated, right? And it will be for the file share, and it will have the following format. So it will be the name of the storage account, .file.core.windows.net. We will enumerate that in a little bit. And the service principal for this application needs manual admin consent, obviously, right? And must be excluded from any multi-factor authentication, right? So the service principal can't use multi-factor authentication, of course, and needs admin consent. The service principal itself that is created does not have access to the storage account, right? So it doesn't mean that if we compromise this service principal that we get access to the storage account. So by default, it actually has not a lot of privileges, right? Almost nothing, right? However, it is still a good target for persistence, right? Let's say you compromise a global admin or an application administrator or cloud administrator, anyone who can add client secrets to a service principal. You can add a client secret to this, or a certificate as well, to this app registration, to the service principal, and use that as persistence, right? Because it will probably not be looked into very closely, right? Even if some type of alert is generated by this account, it would probably just be disregarded as a false positive, right? So interesting target. Why? It doesn't have any privileges by default, but obviously you can provide its privileges, right? So if you add a client secret to that and add some roles to that, you can use that as a nice vector, right? Yes, indeed. Yeah, there will obviously still be sign-in logs, but since it is an application, no MFA can be configured on that, and by default, there will also not be any conditional access policies for workload identities unless the user pays extra, the organization pays extra for that, right? As we covered previously, conditional access policies is only possible for applications with an additional license, right? Then you can create conditional access policies for workload identities. Or if in the organization it isn't even used, you can create your own pre-registration with a name like that. And maybe if an analyst would investigate suspicious behavior from this, they might think they will look this up and they will see, okay, this is probably something from Microsoft. I will not touch that, right? What else can we do with that? Some lateral movement, right? Well, lateral movement is a big word. You will see why, right? It stays here, cloud to on-prem lateral movement, stated with a grain of salt. But if we compromise a hybrid user who can access the Azure file share, we will get access to the files in there, right? So it's just intended behavior, but let's say you encounter this being used, the Entra file shares with Kerberos authentication. We will cover that over here, how you can interact with that, how that works, so you know what it is and what you can do to interact with that, right? But there's no real exploit that we will be using here. We'll just take advantage of normal behavior, right? For example, we compromise a cloud-only user who can reset the password of another user, right? For instance, a password admin or a Rush authentication admin or helpdesk admin, right? Any of that. So we reset the password of a synced user who can access the Azure file share, for example. And then if we have access to an Entra joint device or a hybrid joint machine, we can access that file share, for example, right? You will see that in this learning objective, this exact specific use case, right? This will be the last learning objective for today. So let's go through that really quickly, but if there are questions, feel free to ask them, of course. Okay, so where did we end in the last learning objective? Well, we got the credentials for some users, right? We have the one for the admin account and one for the file admin user. So let's start with this one because it's an Entra ID account. So let's try to authenticate with that. Let's exit this PS session. We don't need that anymore. Let's try to authenticate as a file administrator. And that works, so no MFA in this case. Awesome. Also get a subscription, very nice. Let's see what Azure resources we have access to. And as we were expecting, based on the information we covered in the learning objective, it is a storage account named plant information. Right? We also saw this over here a little bit, right? Because it was trying to access that storage account already. Right. So a storage account, what specific privileges do we have? Let's run get a role assignment to find out. We have two privileges. We have the reader role over the storage account, plant information, and also the storage file data SMB share reader over the storage account. We'll look into that in a little bit, what we can do with that. Let's try to create a new Azure storage context, right, for the plant information. and try to list the storage shares that are in there. And we will see that we get a big error message saying that the API does not support bearer tokens, right? So it's basically telling us you're trying to authenticate with an access token, but this isn't allowed, right? So this already is an indication that some other type of authentication is configured for this, right? Probably Kerberos authentication, because if we go back in the slides, as we said, only one method can be used at a time. So either intra-Kerberos, domain services on on-prem ID. In this case, intra-Kerberos is used, so you can't use access tokens to gain access to that. Right? It will not work. So how can we enumerate that for sure? Let's list all the storage accounts, and let's check the Azure Files identity-based authentication. Right? So there will only be one storage account into plant information. You will get this Azure Files identity-based property. And here you will see there is an attribute named Directory Service Options, which is AAD curve, set to AAD curve. So Azure AD Kerberos in this case, right? So Microsoft can't make up their mind. Oh, is it Entra ID or Azure AD, right? Sometimes they still use Azure AD for some locations, as you can see there. Okay, so we can't access that's with an access token. Let's sign into the Azure portal and see what else we can do. As a file admin user, right? So we can enumerate a little bit how this would look like in the or what this would look like in the portal, right? We already enumerated it using Azure PowerShell, the AD PowerShell module. But let's look at that from the portal, right? So let's go to storage accounts. There is our storage account, plant information. And we know it is using file shares. Right, there's one share in there, plant info share. Let's click on that. All right. Actually, we went a little bit too far. This is where we want to be on file shares. Identity-based access is configured. So let's click on that and see. Here you can see all the options you have. Right. In this case, Microsoft Entra Kerberos is enabled, right? As it states here, with hybrid identities, you will be able to access that, right, from a Microsoft Entra joint device or a hybrid joint device. Right, so this is what we wanted to show here, and who can access that, right? The storage file data SMB share readers. Okay, so how will we get access to the information on that file share, because the final flag for this kill chain will be in there. Let's see, we need a hybrid joint machine, right? So where can we get a hybrid joint machine? Let's look at the file that we got previously. And we saw that aside from the file admin credentials that were in there, there were also some credentials in there for another IP address, right? Local admin credentials, right? So let's take these and try to connect with these credentials, these admin credentials, to that machine, right? Using PowerShell remoting, we get access to that. So the session is created. Let's actually connect to that session, of course. Enter PS session. So now we are on this host. Now what device is this? This server is called KC3 file server. So it's the host name. Right. And who are we? We are the local administrator user of this device. Okay, so let's check if this device is hybrid joint. Then maybe we can use Azure AD Kerberos, right, to access the file share. you can use dsreg-cmd/status to list all of information about the device and whether it is joined towards an Azure environment, right? This is one thing that you will be able to see in here, right? And in fact, it will tell you, is it an Azure AD joint device? Yes, it is. Is it domain joined? No, so it's not hybrid joint, it's fully Azure AD joint, right? Which is one of the requirements we can use either for Entra ID joint devices or hybrid devices, right? So from this device, we should be able to access the file share. Let's create a directory on here called student6. One already exists, that's fine. Let's actually exit over there and import some tools. We will once again be using the invoke runs, right? So we will copy that towards the device that we got access to, right? To our new folder that we created or was already there. Let's copy that. Okay, so it's on there. And let's connect back to the device, right? Now we can be able to use that. Let's quickly disable Defender since we are an admin. It's just the normal standalone Defender. We can just disable that as an administrator, no tamper protection required, but it might otherwise remove some of our tools, which might be annoying, right? And there we will get. So now we will be able to use invoke runs. So we import this PowerShell module, and then we use that to authenticate as the file administrator user, right, with this password, and we execute a different process, cmd.exe, where we list the contents of the plant information storage account. Right, so it is the name of the storage account. We showed you that the plant information is the name of the storage account, and in there is a file share named plant info share. Right? So let's list contents in there as a file administrator user. And if we do that, it might take a couple of seconds to do that. But basically, we will see in there that there will be one file named flag3.txt, which will be the final flag for the skill chain. Right. While this is loading, any questions? I know we went through this last bit a little bit fast, so I hope you guys are still following along and understanding everything. But if there are questions, feel free to let me know. The file share is really taking its time, right? I know it does take some time. I tested this previously, but eventually it will give you the flag. So we'll just wait for that a little bit. Let's, in the meantime, look at the kill chain diagram to understand what we did, right? So the file admin user, which we got the credentials from OneDrive or the mailbox, so both had the same credentials. We found that it had read permissions on the file share that was in the storage account plant information, right? So storage accounts can not only be used to store blobs, but also have the capability to act as file servers, right? But it was protected, or it was only allowing to authenticate to that with the Entra ID global host, right? For which we need to have access to a hybrid joint device or a completely joint Entra ID joint device, right? Which was the file server that we got access to, right? We found local admin privileges in the mailbox and in OneDrive to access that server. So with the credentials of a hybrid user that had access to the file share and a hybrid device or a completely Enter-ID joint device, we were able to access the information in the plant info share, right? And look at that. It's finally loaded. Flag 3 is over there. So now you could use something like this, where you would show the information of that, right? With flag 3.txt, but I will not do that because you can do that on your own during the labs, of course, and submit the flag for Trojan 3. And that concludes today's session. Any questions? All right, so no questions. Next time we will start with curve chain 4, which will be the last curve chain, right? Awesome. Thank you, guys. If there are any questions in the meantime, when you go through the labs or anything, any issues you encounter, just put them in Discord, right? And we will all see if we will be able to help you guys. So thanks everyone, and see you in the next and final session next week.